So start spitting out, spitting out. Yeah, yeah. I see my reputation has preceded me. Yeah, it's okay.
Maybe they're afraid to get slapped if they say something.
It's okay. You're the de facto first row. Is it 8:45, right? Are we? Hear me? Can you hear me now? Yeah, okay, good, good. Is everybody ready? Hi. So my name is Tony Jones. I work in the SUSE Labs kernel performance team, and Giovanni had asked me to give the dictionary definition of BOF. No, actually, I won't do that, but birds of a feather flock together. So anyway, so the purpose of this talk is to discuss some of the things that I've tried to do to change how we build user space programs from kernel source. But mostly what I'm interested in doing is getting advice from people because I've kind of reached a dead end. So there's probably some people here who don't know this. There are actually user space programs in the kernel source tree. And they are located in the top level tools directory within the kernel source tree. And way back in 2631, perf was the first package to be added into tools. By 3.0, we had this many, 4.0, this many, 6.0, this many. And I cannot tell you how many of these we package for sleep, as I have no idea. And that's kind of somewhat of an interesting thing. So, brief history of how tools perf came to be. So there was what's called the dueling performance monitors. There's a LWN reference there. So perfmon originated on Itanium, and it was kernel code with a completely out of tree. pfmon was the user code, libpfm was the library. Posted for review on LKML, led to the perf events counter proposal. And the thing that's important is before all of this, OProfile was the main profiler that was available, and it was a completely out-of-tree user space, and that was kind of regarded as a bad idea, and they wanted to bring that code into the kernel tree. So that's how the tools tree came to be, to kind of bring the user space component matching the kernel component into the tree. So since then, there's been kind of a slight reversal. So trace event, which is to pass the ftrace events, and here's the original commit message. In 2020, that actually got forked into its own Git repository to be used for making packaging easier to use. And libtraceevent.git now gets released as a version tarball as well, and that's what we package in SLE. And by November 2022, it had actually been removed out of the kernel tree tools. And for BPF and BPF tool, something similar is going on because they exist in the kernel tree, but they're also now being mirrored into GitHub. And Xiongxi is going to be packaging these for SP5, and I think it's an open question as to whether he's going to use the GitHub version or the kernel source version. So one of the things is it's kind of hard to know how many packages we actually build out of these dependencies for SLE. There's no real way to know. But the ones that we do, building them to an RPM can be kind of challenging. So how do we build perf at present? So the thing to remember is it's built as a distinct build service package. So there is a perf package, it has a spec file, has changes, and most importantly, we collect the patches for perf in the perf package, not in the kernel source, Git. And that has some advantages. We get a clear change log every time we make a change to perf. We can release independently of the kernel cycle. And there's an implicit indication each time we check a change in that this is going to be a maintenance release, and it's in a format that is acceptable to the maintenance department, and there's an actual change that needs to go out. But there are some disadvantages. So it's hard for others, especially in the kernel team, to check in changes. Somebody's on vacation or somebody just makes a mistake. We could probably prevent this using a hook, but there's nothing that actually prevents somebody from checking in changes for perf into the kernel Git. And back when we were taking stable, this happened quite often. We'd take a stable patch and it would actually be to tools perf. It would go into kernel Git. There's no way to know, no way to trigger an update of the user space package. There'd be no change log. So it would never get released until the next time we actually pushed a perf update out, and then it would mysteriously come out without a change log, and it would be part of the new perf package. And the other thing is that quite often somebody will check a change into kernel Git, and it ends up actually breaking because it clashes with a patch that's local in the perf package. So that's a major disadvantage. The other disadvantage, so Git fixes, they all apply to tools perf, just as they do to the perf events kernel part. But any packages we don't take, we still need to blacklist them in the kernel Git. So we can't get away from the kernel Git. And the other thing I'm going to talk about later, if we want to do greedy backporting, we can't use any of the cool tools that we've developed for the kernel tree. So you're basically taking perf patches, you're putting them into a spec file, you're building them with a normal RPM build. If it breaks, you have to try and figure out in that chroot how it broke, and it's nowhere near as convenient as the sorted series and what Rapid Quilt can provide. And the more greedy we get in backporting, the more clumsy this process becomes. So to quote the inimitable Veruca Salt, so this is what I would like. So what I want to get to is that we maintain the user space patches for everything inside tools, inside kernel Git. That would allow us to use the forklifting or greedy backporting to take large numbers of patches and leverage the tools. One of the reasons I didn't do this before was before we had Rapid Quilt, having like several thousand user space patches in the kernel tree, which all the kernel developers had to sequence when they had no interest, was kind of a problem. But now with Rapid Quilt, that's kind of a non-issue. So what I want is for it to get integrated into the scripts.tarup.sh process. So one thing to remember for people who are not familiar with our kernel tree, we don't have a regular kernel tree like the upstream kernel. We have a Git tree that is a set of patches maintaining Git, and those get applied over a kernel tarball. And scripts.tarup.sh is a tool that basically creates a kernel source directory for submission, and there's two primary use cases here. There's the developers who will run this to create this kernel source directory because they want to use OSC wrapper to either build it or upload it for build. And then there's the branch maintainers who run the same workflow, but they then push the changes into the build service. And what I'd really like is no special handling. So anybody can just check in tools patches as normal, and they will eventually make their way into a SLE maintenance update. And the difficult one, only changed user space packages would get released. So one of the difficulties here, this kind of exists at the kind of intersection of the kernel Git process, the build surface process, and also the maintenance process for SLE. In the past, I know we've had complaints from the build service team that we've messed up our change logs and our change logs haven't been good enough, so I'm kind of working on the basis that change log quality is important. But there's definitely been a degree of procrastination here. I mean, my interest in this kind of, the further we get away from SP0 and the more patches I have to handle, my interest level kind of increases. And then when we rebase back down to SP0, my interest level in getting it fixed kind of goes away, and then it ramps up again, and then it goes away, and so. Yes. Well, except that but now I believe we only go 2 service packs without a rebase, I believe, so it's not so bad anymore. So my focus on this is mostly on SLE. Factory is less of an issue because we rebase the kernel far more often. So looking at CentOS, which is RHEL, they build perf as a sub-package of kernel source.spec, and if I downloaded that packet, I set up a CentOS VM and installed perf and run the changelog, and this is the changelog. So unsurprisingly, it's the entire kernel changelog. So eventually, at some point in time, there might be a perf entry in there. So that's kind of what I was hoping to not get to. So the issue really is making perf a sub-package in kernel source is not a particularly big deal, but generating a changelog is where I've run into the difficulties. So my first attempt So I mentioned we have this thing called scripts.tar.sh, and that basically takes our Git tree, which is a tree of patches, runs the Git rev log on that, and produces this file called kernel source.changes, which is our changelog. And so my goal was to post-process that into a kernel source perf.changes. And that required 2 changes. I had to expand the commit IDs from 7 characters because they actually clash. And we tend to collapse in the changelog, we collapse multiple commits from the same person into one entry. So I had to temporarily undo that. So it takes about 4 seconds for scripts.tar to generate the kernel source.changes, but it takes over an hour to inspect that to determine which of those patches touches tools.perf. And the problem is actually looking at the git diff and inspecting the change to see if it's a perf patch is really expensive. One of the things that makes this worse, so in that 4 seconds, we actually, the revlog is actually 102,634 commits, and every single time you run scripts.tar, we regenerate that kernel source.changes all the way back to the backstop in kernel source changes.old. And it's not entirely clear to me why we do that. I've told there's a reason for it, but the sheer number of commits, we're doing it over and over and over again, it's fairly efficient to process the revlog and look at the commit messages. You can, as I say, you can do it in 4 seconds, but to actually open all those commits and over and over and over and over again is really redundant and takes forever. So, but we end up with a nice change log like this, and it's quite old because most of the patches get collected in, as I said, collected in the perf package, not in kernel source, but they end up with a change log that looks like this. So that was really slow. So I decided that I was going to try and make it a little faster. And so scripts.tar invokes this script called gitlog to changes, which is written in Perl. And I rewrote that in Python to use pygit2 using a topological walk. And it ends up being slightly faster than the 4 seconds to regenerate the kernel source.changes, but same problem as the prototype. As soon as you actually have to inspect the commit, the performance just goes down the toilet. It's about 4 seconds per 100 commits, and I said there's 162,000 in the revlog. So I posted long ago on the curling mailing list about this, and I said this is the problem. And the main solution I got was, well, why don't you use the expanded tree? And for people who don't know, the expanded tree, as I said, we have a base tarball, and then we have a Git repository full of patches, and scripts series to Git is used to basically create a Git repository from these. And we can also check it out directly. But the issue is that it's notional only. So, I mean, it's not part of the actual development process. It's purely, if you want to use it, you can use it. But the actual branch maintainer still runs script.tar.sh to push the changes into the build service. There's no expanded tree. So using it is just kind of complete tangential to the problem. So the other thing that's kind of come up from time to time is, well, why don't you go ahead, put the patches into kernel Git, but do the work somewhere else. Like do it in the kern CVS backend somehow. Still package up as a separate build service project in perf, but build require kernel sources before, but somehow this changelog will somehow mysteriously arrive from this out-of-band process. But I mean, there's a major synchronization problem here because it's unclear when the kernel source actually becomes the new kernel source. I mean, it goes through, it gets released, it comes out of maintenance, and eventually it'll appear in kernel source. So you check your patches into kernel Git, but when you actually have to loop back and package it into the user space package is really unclear. So I'm kind of iffy on that. So bottom line, to me, to do it this way, the performance needs to improve. So we need to inspect less commits, which means we need some state. And the only state we have right now is that RPM kernel source.changes.old backstop. And whenever I've brought this up before, there's been a legitimate lack of interest in creating any more state in the kernel tree. So the way to do that is either via global change impacting that backstop or a more limiting backstop just for the perf user space changes. One obvious way to do it, tag the commits on the way in. So scripts.log, it looks at the commits at that point in time. If they touch the user space, tag the commit message. We've already seen that we can process the commit message really quickly. And so only look inside the commits that we've tagged. That would make a significant improvement. So I was talking to Mikkel about this a week ago, and he said, well, look at this. And so I thought I'd tried this. So there's a kind of an optimization based upon our Git layout. So I'm not picking on well, this happens to be a commit. So if we look at this commit here, so the things that of interest are, there's the tree object, and there's the parent object here. And so basically, if you run git cat file on the tree object, this is what you get here. And the interesting item we're interested in is patches.susa, which is where we collect the actual individual patches for a commit. And that's a tree object also. So if I do something, so this command here, the first commit ID is basically the patches.susa tree object, and the second one is the equivalent for the parent. So if I run a simple diff on that, I get the patch that we've added. So in theory, it's possible to use this as kind of a slightly more optimized way to go through and figure out, since I know this is how the Git repo is laid out. So I already had this Python code that I wrote, and so basically this code here just takes the tree, takes the parent, and then it iterates over the tree to find the patches.susa directory. And that's pretty low cost up to this point here. It's about 3/1000ths of a second for every 100 commits that we do. But as soon as I try to iterate over the entries in patches.susa, the performance drops to 6 seconds for every 100 commits. Instead of doing, so there's obviously a problem in the Pygit implementation. If instead of doing this iteration, I just popen out and run that diff command, it's about 2 seconds for every 100 commits. But, yeah. Can you use the mic? Yeah.
Have you tried using the key lookup for the tree object? So instead of iterating all the entries, you just look up a certain path in the parent tree.
For what? But for the first, you mean for patches.susa?
Yeah.
Well, this is really fast. I mean, as I said, to get to this point in the comment, it's super fast. The problem is generating the list of commits that are in the parent directory so that you can diff the two of them to figure out what's the commit.
I see. I missed out on this.
No, that's okay. No. That's okay. Good question. Yeah. So I don't know. So the summary is that Git optimizations may help, but the performance is still an issue. So to me, reducing the scope of what needs to be processed is really the best approach. And like I said, this is a copy from the previous slide. And there are some other issues. So one issue is just considering perf. What would be considered a perf change? Because it's not simply what touches a patch that touches tools perf. It's actually perf makes use of patches that touch parts of tools lib, tools BPF. So that's one more level of complexity. The other question is this anything of interest to anybody other than me? And I mentioned, Sheng Si, he's not sure if he wants to use GitHub versus the kernel source. I talked briefly, Thomas Reniger maintains, as I said, it's hard to tell, but it's hard to tell which packages build require kernel source. The one nice thing about how Fedora handles this is they package everything into one kernel tools package, and right there, these are all the and everything is built as a sub-project from that. So we don't really know this, but I know he maintains TurboStat, CPU power, and a few others. But these are really low number of changes, low number of Jira requests, low number of Git fixes. And I mentioned this to him, and he didn't have a tremendous amount of interest. Oh, yeah.
Just really only wanted to quick mention that, yes, it's interesting, for example, to me as well, if in the context of maintaining KVM stat, which is still there. Okay. And for now, I use the approach that you said you are using. So it's
Yeah.
it's its own OBS project which imports the kernel sources and the patches, which are mostly backport. So I have only a few patches. That's why it's not a big burden. Are in the OBS
Right.
project for
Right.
KVM Stat
Right.
itself.
Right, so you have the same problem, which is somebody can check in. I mean, we could put a hook which prevents anybody from checking in a patch into the kernel Git, and we still have the same problem that we can get these clashes and stuff breaks from time to time.
And also there is a Linux GBC devel, so that's a so Linux header files for the user
Yes,
space. Yeah.
yes.
That should be also generated directly from kernel source.
Yes, good point. And the other issue is, the one nice thing about how you package this and how packages perf is that we get control when it goes out. I don't know if you happen to look at that RHEL CentOS release, but that changelog was the kernel changelog, which implies that that package is being issued every time, whether there's a perf change in there or not. And I believe that it'll be the same if we package any packages. Go ahead, Robert. Oh, so I believe that that's going to be the case, which is that it's not the end of the world, but it's not ideal. I mean, it would be the ideal is that especially if we had some of these packages that don't change very much. If we were to generalize this and ship 20 or 30 different user space packages out of this, do we want to issue 20 or 30 user space packages into maintenance every time we issue a kernel update when none of them have changed? It seems kind of a hassle. Maybe it's not the end of the world for perf. And there was one thing, in factory this would probably be solvable via the reproducible builds concept, but that doesn't exist in SLE. So, and Robert, go.
So have you considered using the source service? So we have a similar problem for our image descriptions, cake recipes. And what we do is basically we store the state in the package and then let the source service check out the Git repo, take the state from the file that we have in the package, which is the previous commit, and then diff just between the previous commit when it was generated to the latest commit, and then you have a much smaller set to process to do the changelog.
No, I wasn't even familiar with that.
Yeah, so you can have a script in IBS, basically let it check out the kernel Git, and then you take the state from the package, which is the commit number.
So how do you know when to do that, though?
Well, you just run the source service whenever you want, and then it takes the Git tree.
Well, sure, but I want it to happen when I check in a kernel's.
Yeah, you check in the kernel, and once it's in Git, then you go to the package and you run source service all, and then you get the diff. It's quite simple, actually. And then you just have the difference between the last time you generated changelog and now, and that's a much smaller set that you process. I'm sure your timing issue goes away.
Anybody have any comments? I've never used this, so.
Yes,
Oh.
there is the thing that for Linux glibc devel, it's not acceptable for it to be released with each kernel release, because everything depends on Linux glibc devel, and that means that with every kernel release you would rebuild the board. That's not accepted.
Mm-hmm.
Also, the going discussion right now for the ALP is that we use multi-build stuff instead of the linked packages. So that was a request from the ALP. And if we do that, that is a problem because it means that it's really always rebuilt. For example, the path package, we cannot do control, so at which timing it should be built. So in that case, it cannot be the linked package or some multi-build. It's not easy. So somehow path would depend on the kernel source or whatever. So different mechanism is needed.
Did you thought about to just use for the changelog all the commits that are on top of the base kernel version in kernel source? Because that's what I was looking into for Linux glibc devel.
That is, I mean, this is our set of patches. I mean, it's hard to explain. I mean, the revlog is our Git tree that's over the base kernel source version.
Yeah, but you can, but
Yeah.
if you can identify the commit where we changed the base kernel version and just go from there, then you should just get everything on top of that.
Well, sure, but that is several thousand, several tens of thousands of patches, probably.
Yes, but not
Well, no, sure.
200
No,
or
no,
160,000.
no, sure.
So how do you identify the commits? Do you grab them for some of the?
There's a
paths?
match. There's a matcher in libgit that you can match against a commit and find out if it matches against a particular path.
So
Otherwise, you can
could
just
you like first match everything under patches SUSE and then give the list of the patch files to git log -- and the list of patch files that
possibly. I mean,
should be faster maybe.
maybe yes. So there's possibly a way to do it which doesn't involve using the kernel. I mean, my goal in doing this was to do it as a side effect of generating the kernel source changes file, but that's clearly not going to work.
You only need to scan the changelog only from the last entry, which is already in the perf changelog, right?
Well, except we don't keep that change log in the tree. I don't believe.
Yes, but you can grab it from the build service or somewhere. Sorry.
There is no ordering of the commits. You can merge all commits, but there is no ordering.
Yeah, this rebasing and merging of all commits and why we walk back is part of the problem, but I'm not sure of the reason why.
There is no ordering of the commits.
When we listen back to this, we remember it was an insightful observation.
So for BPF, I'm actually still I still will have to do the kernel source. Well, the same thing as you for the 15 SP3 to SP5, because I'm not moving to GitHub. I cannot really move to GitHub for those. And for the ALP and possibly SP6, maybe. So like I might end up getting the best of both worlds or the worst of both worlds, depending on it. And so another thing is possibly a stupid question, but if we put all the patch for the user space in a different directory, like patches that tool, I guess, like would that help?
Yeah, I mean, given the performance issues in iterating over that large of a patches, that could help. Yeah, if we had patches.userspace. But still, the fastest way to do it is I think is just to tag the patch on the way in. I mean, at that point in time, I mean, I mentioned this to Mikhail, and he was concerned that we'd somehow miss patches in doing this, but I'm not really sure how that would be. I mean, when we run scripts log, if we identify that this touches a user space, we put a tag in there saying this is a user space, and we added it in after the commit log that the user specifies, and then we can find them really fast. That just seems like the easiest way to do it to me. And then after that, there's a variety of optimizations we can do if that's not fast enough, such as, I mean, given how fast we can scan the entire 163,000, and given how few user space patches there are, I think that alone will probably solve the problem. After that, we could do various options of limiting the scope of the patches. But that's kind of the change that I would like to make, is to put that to and I think that putting it in scripts log is good enough. I mean, that would catch. I don't believe there's necessarily any ways around that, but maybe there are. But
Are there any dependencies on other header files or something like that, which are not in tools directly?
yeah, there's dependencies on tools include, which gets itself mirrored through patches from the regular include file for various reasons. So, yeah.
What you could do, there is
Can you use the mic? I was asked to make sure everybody uses the mic. Sorry.
Can you, if there is few patches for perf, can you like put the list of patches that touch perf in a file? Like we have a list of patches that should be excluded from the changelog, and we have a list of patches that should be excluded from git fixes and stuff like that. So you could put a file into the kernel source that says, this is the list of commits that include perf changes.
Sure. Yeah, I mean, it's slightly awkward, especially if we generalize it to other things other than perf, and it's one more thing that somebody, I mean, I guess we could have the hook or the scripts log update that automatically somehow if the patch touches. But yeah, it's entirely possible that we can, I mean, there's lots of ways we can do this by adding more information to the tree, but when I brought this up before, it was like, no, we don't want any more state. You know, so everything's possible if we so what Michael's suggesting is we basically have a file that basically represents patches.tools, I guess, but
I just thought that it's not, right now that whether it makes sense to put the patches in different directory, so not patch SUSE instead of patches SUSE, patches tools or whatever, then define SH.
I mean, I still think that if we just tag the patches on the way in, that we will solve I think we'll find we solve nearly all of the performance problem, because we're just not going to have, it's going to be very fast to find them.
Yeah.
And they're relatively small as a percentage of the total number of patches.
Yeah, but sorry.
Unless somebody sees a problem with that.
But my primary question is that changelog so important? I mean, there has been always complaints from people that kernel changelog is way too huge. And for in the future, we want to strip down make it small. And I wonder whether we want to keep that.
Right, that's one of the reasons why I mentioned this, is do we want to revisit that backstopping procedure here and change that? Because obviously that would have a side effect on this as well.
Yeah, but it's not necessary to put every single commit change in the changelog too. We can just put the commit log, and the details change can be referred in somewhere else, or we put some text, so change commit log text in kernel source package itself also.
Yeah, sure.
Yeah.
I mean, all that I care about is in the end, when this gets to the maintenance team, if there's not a decent changelog, they're likely to object. I mean, they have in the past, and I think if I gave them that changelog, they would probably have a minor flip out. So, yeah.
The big changelog is also an improvement for support and from support. So if customer asks, point me to the change, that is important for us to show it to customer. Here is the change that fixed this issue. You have to update the kernel.
I understand. Yeah.
Man was queuing for information commenting.
Just going back slightly, I think you're suggesting on tying this into the series log and enforcing it by GitHub would be like tagging the patches individually. So if the patch being added touches tools at all, we already have like mandatory metadata like patch mainline, references, the correct signed off, they're all enforced. And just say in the event that you're committing a patch that touches tools, that there is a new meta tag that says kernel tools, and you name what it is. So like it would be perf or turbostat or CPU power. There would be a need to go at one point to update all existing patches that affect perf and annotate them once. But you would need to enforce that at the GitHub level, because not everyone uses scripts.
Sure, but we'd also need to, it can't just be in the patch. It'd have to get copied into the patch description that gets fed into the changelog. Otherwise, once you start having to actually open the patch and look at the header, it gets very slow.
It would get very slow.
Yeah. But scripts log does that already. I mean, it takes the Bugzilla reference out of that tag and it copies it into into the commit message.
So it could do the same.
Yes, correct.
So it enforced a kernel tools meta tag.
Yes, sure. Yeah, no, it's great. So what Mel's saying is that we add an extra tag, like instead of patch mainline, would say patch user space : true or something, and then scripts.log would pick up on that and enforce that
and then enforce it in the Git hooks, not necessarily. Well, scripts log could warn about it, but enforce it in the hooks. So even if someone has the hooks disabled on their local repository, which is common,
right,
it would still get kicked back when they would try and push it to current CVS.
Yeah,
And
sure.
I think would be the most reliable, because they say and put it into a separate directory, people will forget. There'll be mistakes made.
Right.
Whereas we have lots of practice dealing with the metadata ones, and a new one that occasionally touches tools should not be.
Yeah, and I think this is pretty lightweight. I don't think most people won't even notice it, and you know.
Most people, with the exception of yourself, will hit it if they get enthusiastic about Git fixes.
Right.
And then when it bounces back from current CVS, like it's one quick eyeball roll, throw in the tag and push it again.
Okay.
It'll take them about 5 minutes.
Okay. Thomas, give us the naysayer view.
Yes. I mean, in theory, the stuff should be totally separated. This tools directory should build out of itself. In practice, there are some include files taken from the kernel, but these are bugs.
Well, that's not true. That's not true. There's a separate tools include directory that, through patches, gets mirrored from the include file in the kernel. So
yeah, but they're bugs. They should theoretically be cleaned up. I'm not sure how much they are for perf, but I had some. But anyway, so theoretically, the whole thing should be separated and built simply by make inside of the tools directory. Theoretically, you should be more or less be able, to copy away the tools directory and
but that sounds like an upstream problem.
Yeah, I mean you are familiar with the kernel tools, but it makes things even more complicated. It's the same. I could imagine it's the same for the upstream people to get away from this, because you have the whole big kernel stack at your feet. I would more go the way for more separating the stuff. You have for some tiny tools, you need the whole huge kernel.
Sure, and I understand what you're saying, but I mean, this is kind of we're stuck with we were using the upstream method. I mean,
I'm not sure whether is there a Git submodule on this tools thingy. Would that help to more separate this down?
No. I mean, the first thing is, I mean, if we do implement this, I'm not going to run around saying you can still have a user space package that build requires kernel source, and you can still put your patches into the local, if that's the way you want to do it. I mean, honestly, I mean, that's totally a-okay. I mean, it's especially if you've got a small number of fixes. The problem for perf is that the fixes are far more numerous, and as we get further away from the service pack, the backporting gets harder, which means we really need to do more aggressive backporting, which means that I don't want to use the local package anymore because it's too cumbersome. But if you have a simpler use case for yourself, keep on using it. That's fine.
Yeah, let's talk about this offline a bit more,
sure,
and let's find something in the middle. Maybe.
All right. Well, thank you, everybody. I appreciate it.
What's the time? So that I understand one thing, we're moving away from Robert's suggestion of storing the state in the package, right? The discussion veered away from that suggestion. Do I understand?
No, I'm going to talk to Robert and get a better idea of what he's doing and look at it. I mean, one thing that struck out to me right away, what if we have like 10 or 15 different user space packages all doing this? I mean, we could put them all into one kernel tools package like Fedora does.
Yeah, I mean, you just write a source service for every one of those packages. It checks out kernel source from Git, and then you run, I mean, I'm going to say you can probably even use the script that we have.
I thought you couldn't, I thought there was no network access to check stuff out of Git.
So you run it locally, you run the source service locally, that will generate your diff and your tarball if you want. and then that's what you check in. But the
I mean,
service itself is disabled
So
inside of
the one
build
thing that
service.
one thing that I think maybe that would solve is this issue of what happens when we publish these packages in the kernel source. You know, what if it hasn't changed? Do we end up issuing an update for all these packages? That might give us some control over that, because if we do tag the commits on the way in scripts.log, we still have the problem that we're going to basically release every one of these user space packages every time, and your solution might solve that.
Right. I mean, you control when you want to push
Yes,
it.
yes,
right?
that's what it sounds like. So we
So
yes.
in a local project, you would run the source service.
Mm-hmm.
You generate everything and make sure it looks like the way you want it. Then you run branch checkout from the SUSE namespace. That's what we do, and then we just copy it back in and submit that, and then we're done. Right? I mean, yes, it's a two-step process for you, because you have to go and commit it to kernel Git.
Yes.
And then
That's okay.
and
That's
then
okay.
manually go into
Right,
the
right.
package and run that.
So the issue I have is I don't want to commit stuff into kernel Git and then have to have a build requires kernel source, because there's a disconnect there where you have no idea when this is actually going to emerge into the kernel source. But 4 minutes. But this sounds like it might solve it, and it doesn't preclude us tagging the commits.
No, it doesn't.
Anyway,
No,
so,
it doesn't.
Yes,
Yeah.
yes. Yeah, well, thanks for the suggestion.
One
I
comment
appreciate
maybe,
it.
Michael Sukanek, you have 4 minutes. There is plenty of time if you want to.
Okay, there is additional automation for Git with OBS, which I'm not quite familiar with, but some people like have automation that they push stuff to GitHub, which is already done automatically with kernel source. And then when there are changes on GitHub, the new package is uploaded to OBS, to a development project. And it's built, and it's tested that it built. And then you can submit the changes when you think that it's
Right.
good to submit.
Right. Which sounds somewhat similar to what Robert is saying.
Yeah, it's just automation for the surveys, so that you don't have to check out the package and
Right.
run it by hand, but it's done by some automation.
Right, right.
A quick comment.
Yeah, no, just saying that what Michael just said is also what we are moving to, and partly already moved to for a few packages, us in the virtualization team as well, namely QM on libvirt. The problem is that which we are also trying to solve, also related to the changelog, is that yes, these very convenient automation are also able to generate a changelog. What we, and I want to talk to Robert as well, because about how do they do that, because maybe it can solve our issue. The changelog is fine, but for example, it doesn't have the BSC references and stuff like that. Instead, we want that, and yeah, right now I have to go there and do it by hand, but
Okay.
yeah. But
Okay.
they're actually good, and they
Okay.
works fine.
Okay, well, I'll definitely touch base with you. But yeah, well, maybe we can touch base as we go along and see if we can kind of fix it for both of us.
Well, as far as I know, the service puts the messages from the from the Git log into the changelog. So if you put the bug references into your Git commits, then you get the bug references in your changelog.
Absolutely. What I don't want to do too much is especially if they are backports, I don't want to alter the subject of the patch or commit with Git. And also, it's also more work, because I can just do a cherry pick and the patch is backported, and then I commit to the Git repository, and I'm fine. If I have to add the BSC reference there, so, well, yeah, maybe, I don't know. I have to add it in the commit message at least. So,
But you're
One minute.
interested in basically adding your commits into with the perf into kernel source.
Yeah, I
Fine.
mean, you don't have to piggyback on the build service for everything, right? Because you can write a custom changelog generator, right? So you use right? You use the build service for what it already knows, which is how to check out stuff from Git.
So when you say build service, does this apply to IBS as well as OBS?
Yeah, IBS and OBS.
Because
Doesn't
IBS is
matter.
the main
It's
interest
the
that I
same,
have.
right,
Yeah, okay.
yeah.
But
It's the
it's
same.
not always the same. Okay, we're done.
No, it's the
We'll catch it offline. Thank you, everybody. Thank you.
Hello? Okay, let's start. I will talk today about the Python packaging Messi. And this is me. I'm Daniel Garcia. You can find me at this email and these usernames in different platforms. So if you find that I break something, you can blame me. So let's start. What is a Python package? I will talk about real Python packages, not RPM, and maybe later about RPM, but not much. So what it is, or yeah, or what we have here. We have one of the good things about Python is a interpreted language. So you have the code, and you don't need to compile for different platforms. You just put the Python code there and run in everywhere. That's not true, but is the idea. It's almost true. So if you have an interpreter, you can run, or hopefully it will work. So a Python package right now is just a zip file with all the code inside. Yeah, but it's simple because you don't need to compile anything. You don't need architecture. So if you have Python code, you can just create a zip file and put it somewhere, and the people can download and just unzip and add to their Python path, and it will work. It's simple. Why do you need more? Yes, we need more because you may know it's not that simple. So we need the metadata. We need the versions to be able to update or to know what I'm running. You have the dependencies. That is really nice to be able to build something bigger, but it's a nightmare. And yes, at the end, you have interpreted code, but not all the Python is just Python. You have C libraries, you have dependencies on binary code, so some Python modules don't work everywhere. You need to have different packages for different architecture. And yeah, about one important thing about the packaging is how to distribute that. So you need trusted repositories or some way to download, because if you download the Python code from a random website, it could be anything. So this is something that we have in all the Linux distribution, but some languages has their own thing to distribute code. So when we are talking about Python, Python has their own packaging system and distribution, but why there are a lot of people working on packaging before Python started to create this, but why not use something that exists? But I don't know the reason. I was not there, but I think that we almost everyone that works on software has done that. There is something, but I don't like it. I will do better. So, and this is free software, so it's about choice. So I can do myself the thing and do better. So that's partly true. It's not true, but that is it. If they could use RPM, maybe things could be easier for us, or maybe harder. But the thing is that it's a packaging system, so it's very similar. So you can maybe translate one-to-one. But let's go about the history, so to understand what we have right now and what you have seen or will see in different Python modules. So in the beginning, we have these utils. This utils was the first way to, official way to build Python packages, and it was part, or it is part of the Python interpreter. It's in the main library, the standard library. For now, it's deprecated right now, but is what we have. The problem with this solution is that it's because it's in the Python standard library is coupled with the Python version, so it's not easy to update. You need to do with the Python interpreter that is more stable, or should be. With this, we have an introduction of setup.p. That is something that is everywhere today, and people are removing it, but it's everywhere. And the requirements thing, that is not standard, but it's a way to handle dependencies. And the way to install packages with this, running a script. It's a Python script at the end. And it just does the packaging thing, just copy all the code in a folder and create and install in different places depending on extension and all the thing. So we can build RPM directly with this. So this is cool. It's nice, but has some problems. So the next step is setup tools that comes later to solve some of these problems. So setup tools is an external tool, so it's not coupled anymore with the interpreter, so it could be updated faster and do more creative things. And at the beginning was just something on top of these utils, but right now it just replaced. And does basically the same, but extends. It adds the ability to add requirements, to add dependencies inside the setup file. So you don't need the requirements thing. You have in the same build the dependencies. So during building, you can handle dependencies, or during install. And we have the .r file format. That is basically what I said, a zip file with the metadata and the code. And at the beginning, the egg files can be installed just putting the zip file in the Python path in some place and just adding this to the path. So you do not uncompress that. You use directly the code from, you import the egg file. So the unzip is done at runtime. That is good for Python because it's fast. So you don't have performance problems. And after that, we have the wheel. That is basically the same, but an extension or a new version. So the old way of installing and building Python packages is using the setup.p. So you run setup.p build or setup.p install. That is deprecated, and you shouldn't use that anymore. It has some problem. I think that the main problem is that it's a Python script, so you can't put any code inside there, and it's not good to. It's not something really able to run random code, building the packages or installing. So right now, for building packages and installing, you should use pip. that has the same functionality and something more standard. And it's able to create the wheel packages instead there. And yeah, I have a comparison here. So we can see the difference between X and wheels. So it's very similar, but try to improve to remove the problems from one side to the other. So both of them add zip files with metadata in different folders. In egg, you can find in egg info, and in wheel, you have the this info. And yeah, even the name of the packages has metadata because it has a format. It's the name, the version, the Python version, the platform. It's in the name of the package. And there is another difference that the egg file has inside the Python compile code. And the wheel only have the sources and it compiles at install time. So right now, the modern packages are wheel. All packages are egg. And then we have the new format trying to standardize this and open the way to build Python packages to external tools, to more external tools. So we have the PyProject TOM file definition. So instead of adding the metadata to a Python script, that is the setup.p, you have the metadata in a TOML file. And yeah, it's a standard, or try to be a standard. There are different tools. You can use different tools to build and to install. Not to install, you should use pip, and even to build. But pip rely on external library to build. So we have now setup tools, fleet, poetry, and a lot of things to build, not just setup tools. So if you are building Python packages, now you need to care about more dependencies to be able to build the packages, because before you just need setup tools almost always, and now there are more things to consider. We have some metadata, and it is extensible, so tools can add their own metadata in this file. So that is something that's good, but it opens the door for every tool creating their own metadata, so every tool does the same thing with a different name. So it's harder for find a standard way to do things. And what about the future? This is a brief history about this. So now we know why we have some Python modules that have the setup build, some that doesn't have that and have a PyProject, some that has the requirements file, other doesn't have that, and have different dependencies for building. But what about the future? So this utils is deprecated and will be removed in the next Python release. So if someone is using this util, he shouldn't. But you can continue using, because this util is inside setup tools, so you can just rely on the external module and continue using that. And yeah, the future is the PyProject TOML, and tools are building and doing different things on top of that. So I think that in the future, there will be more standardization inside that file, because now tools are adding their custom things to do more things, not just packaging, and maybe some of these things will go to the standard, just to use the same name for everyone. and not have different configuration name like test dependencies, and other tool use depth dependencies, and other tool use extra dependencies. So a standard way to define some specific case that are common. So I have been talking about creating these the packages, but there is not much about how the Python packages does the dependency tracking and all the thing. So it's in the, as I say, in these utils there is no way to specify dependencies. You have an external file, requirements with all the dependencies, and that's all. And then with setup tools, you have a way to define dependencies. But a lot of people continue using the requirements because it's a standard, and there are people using different names for requirements. So you have requirements, depth requirement, doc requirements, and different kind of files or metadata that is not a standard, but different projects use different ways of defining and handling dependencies. And now with PyProject, it's easier to add this metadata into this file, but there is a standard way to define dependencies, but tools has the ability to add their own configuration, so tools are using different names. So that's the thing. The dependencies tracking in Python is something that is done at install time with pip, because when you build the package, you have the metadata and everything is there. But before building the package, you have in the source you have different ways to define the dependencies. So when we talk about RPM, it could be really easy to just translate from a Python package to an RPM, and even we have some tools to do that. At SUSE, we don't do that automatically, but we have some tools. So you can get a Python package, a wheel, or not a wheel, the source, and just translate to a RPM. It's really simple. We share even the similar, or we try to use the same name, just with Python prefix. So you can even translate, but as I say, it's not always that simple. So it requires some review. So right now, to build packages, we just get the source from trying to get the Python packaging index from the repository. If we need something more, we go for the source where it is in GitHub or wherever it is, because sometimes we run tests and the tests are not part of the distribution, so you need to get the source with more data. We handle dependencies with RPM, so we need to translate the dependencies in that project to RPM dependencies and handle missing dependencies. So yes, that's the thing. Python is a language that grow a lot, and it's really easy to depend on half of the internet to just do something really simple. So when you add a dependency, or when the developers add dependencies, it's really easy to don't think about the overload. So you add a dependency to do something really simple, and when we try to add to RPM to SUSE, we end up with 30 new packages, or 30 or more. So we have some macros to be able to build because of this history that I have been talking about. So there are different ways, and different modules are faster than others. So we have modules that use setup tools and others that use these utils. So we have some macros that does the installation and the build process, trying to be more simple. So we do not need to care about all the things. And yeah, we have the PyProject version of the macros to handle this. And in the Python packages, the check part is really important because it's a dynamic language, so it's really easy to do not detect incompatibility problems between dependencies. So you need to, or you have to run test at some point, because you can update and maybe this with the new dependencies is not working, but you cannot detect because you are not building anything. You just have the source code. And we have the multi-build thing in Tumbleweed. We build every packages for three version of Python. Right now, 3.9, 3.10, and 3.11. And this is done with these macros. So, yep.
For the package is the same?
Yeah.
What's the difference, and why do we need to build it 3 times? What do we build?
It's not always the same, but it could be the same, but we build different packages to be able to install. The files are not in the same place. We have, for Python 3.9, we have the files under the 3.9 namespace. So you don't have a collision. If you're using 3.9, you install the 3.9 and not the 3.10 thing.
It's because we compile to PYCs. And PYCs are linked to the Python version that they run against. So you can't take a PYC for Python 3.9 and use it for 3.11. It will then get rebuilt. That's why we include them in there. And that's why we're doing it this way.
Yeah, and a lot of Python packages are not just Python. There is a lot of C code. So it's not that simple, as always.
And if I may add one more comment, these two sets of systems of building, Python build and Python install versus PyProject wheel and PyProject install, they are not the same in the sense that the first one is being heavily deprecated because it stopped working with Python 3.12, which is now in alpha, so we really should, and we have like thousands of them, so we have to really do something about it and to convert from one from the other. Basically for you, please don't use the first one if you can.
Yeah, that's the thing. With Python 3.12, we will have a lot of packages broken because of using this utils thing.
So I have another question. So this bytecode actually builds blastingly fast. Why don't we build the bytecode at install time and post-install?
I don't know. I don't know if. So at a post-install?
No. The PYCs are built blastingly fast if you install the sources.
Blastingly fast is not fast enough.
And we are running tests. We are running tests.
Where we will be very slow comparing to Red Hat. It's not that blastingly fast in some situations.
Yeah, so this is what we have. This is what we're doing. And this is what we are facing every day. I have been talking about this. Python is a dynamic language, and yeah, some people doesn't like too much to keep the API stable. And even when library developers keep the API stable, other developers like to use internal things. And in Python, you don't have an isolation thing. You can use a library and go deep and use some internal thing. And if the developer change and keep the public API, maybe it break your code because you are doing crazy things. It's hard to detect incompatibilities because it's an interpreter. So so if you don't run the code, you don't detect the problem. So that's why the tests are really important here. And yes, the thing that I said before, the dependencies thing it's a problem. It's not that bad that JavaScript, but we are trying to achieve that that thing. I mean, when it's easy to get a new dependency, it's really simple, or it's really easy to that your project grow a lot in dependencies, because when it's simpler to just add this dependency and it downloads from the internet wherever and it works, it's simpler than go to the standard library and try to understand the API and write 10 lines of code if you can import a module and write one. So that's the thing. Maybe one package, if you want to add one package to OBS, you end with 30 or more. And we need to maintain that. So there are a lot of Python packages. And when some packages change, there is a dependency chain and everything is broken. So we need to go one by one fixing and reporting upstream that you are doing wrong. So, and we have been talking about Python and RPM. So I will talk a bit about something that we are working on, trying to solve all the problems that the people have in the world. So we call this the Python stack proposal. And it's not something really big, but I hope that it's something good. So the Python stack proposal is just we are trying to solve the problem that we have with SLE and all Python packages version, and people relying on all Python interpreter and all version. And we want to provide a new interpreter and a new set of modules on SLE with all the support, but with a modern version. So you can use a modern Python. This is not a replacement of anything. And the Python 3.6 is continuing to be the main Python interpreter, and libraries are there, nothing changed. But we are building the new version of the Python 3.11 and not to reduce now, but a reduced list of Python packages that are the newer version. I mean, right now the version that we have entangled with, but it will be stable in time. So we are taking the version right now to provide a new version. This is going to the Python module for SLE, and as I say, it will be supported at least until 2027. And the Python modules won't change like it's saying untampered with. It will be more stable. We'll try to keep the Python stable, the Python module stable, but we can update this. It's really difficult to backport fix it or something. Yep.
Just two bitchy comments from somebody who spent too much time with this. First one is, we do not, this is not a SLE. Well, it's not the same as the base SLE. So we do not guarantee, we will try to be stable and keep it stable as much as possible. But this is not like the SLE that it will be forever and forever and forever the same version. So anything can change. We will try to be very reasonable about it and change when necessary, but it is not guaranteed API forever. That's the first one. And the second, I will be really nasty if you want to add a new module to that restricted reduced list. So I want Jira tickets, business reasons, all the crap. So yeah. Just, yeah.
Yeah, I don't know how many packages that we have right now. Less than 600. But we started with 200. We started with 200, but need to add dependencies and dependencies. So it's a never-ending thing. So to add a new thing, we require to to add a lot of things. And we need to stop at some point because we want to support this, and so if it's bigger and bigger and bigger, it will be a lot of more work. So we try to not have tumbleweed here because it will be a lot more complicated, but to provide some basic thing to be able to build on top of this and to modernize the tools without breaking the base system. So that is all that I have. So if you want to ask anything, it's the end. This is the end.
Are there efforts to take upstream dependencies instead of redoing this, or even taking whole packages? So, for example, in factory at least, just hit the button and we have Python 3 dot whatever with a whole bunch of packages, just like that?
I don't understand the question.
Yeah, I mean, there are, with pip you have all the requirements and the dependencies, and we are redoing this with RPM, right?
Yeah, we are translating from...
So I could imagine kind of source service or whatever, where the package is going to be fetched and an RPM is going to be built.
It's not that simple to convert.
Yeah,
I guess
yeah, it's
so.
not that simple.
My question is, are there efforts?
The simple answer is no.
Yeah.
So you can elaborate, or I can elaborate.
Speaking as a member of the Python team, though, if you want to add something to reduce stack, we do accept non-sequential unmarked bills.
Non-sequential unmarked bills for cache, dice cache.
Yeah.
Concerning the question, there are always somebody comes with a great idea that we would just replace all our work with just automatically pull down everything from pip and everything will be awesome, nice and shiny. It won't. Point A, we are actually SUSE and we are selling some support to people. So we are supposed to guarantee that it actually works. And
also, PyPy's uptime is 99.6.
That's the other one. But the first one, you wouldn't believe how much the Python developers haven't absorbed the idea of a stable API. That's just a weird thing. So,
or solving it with vendoring. Just include your dependency in your package. And it just
no, just put in your requirement lists less than something and everything will be shiny. Yeah. So it just doesn't work this way. Currently we are battling with Eurolib 3, which is Foundation for Requests, which is used by like half of all Python packages, which lost compatibility with the older versions, and it's horrible. So no, I will never ever allow or sign up on just use pip and everything will be shiny. It won't.
Yeah.
So I have a question, especially for the SLE part of the
Yep.
Python 3.11. So what's the actual business case of including any Python module? I mean, if we only include 600, then which is there a customer that's happy with just having the 600, or are they just going to vendor everything they need on top anyway? So why don't we ask them to vendor all of them?
We were working extensively both with our external customers and with internal use. So, for example, there is cloud team who uses Python very much, and we were communicating with them what is the list they require, and I don't know, Ericsson and so some other customers we were talking with what they need from us. So it's kind of, that was the process how we developed that list.
Yeah, we try to create a list of basic packages that most of the people want, but you need to code at some point. You cannot add any dependency that everyone has.
Yeah. So what's the actual support we promise for those Python packages? Is it like we will pull bug fixes from the internet, or do we develop? Basically promise to maintain even upstream unmaintained modules? Okay.
Actually, to answer Rich's question, there is another very important reason, and these are other packages that are not native Python packages, but which have Python requirements, and so they create dependencies. In order to build them in the build system and ship them, you actually need to provide these dependencies.
So regarding this stack proposal for SP4, could you maybe share a little on how that would relate to what SLE-BCI provides, and maybe any kind of update on what kind of Python to be expected with ALP?
I don't know. So
HPC, meaning like scientific stuff, or high performance. We are not including anything. I'm not sure whether we have MathPy, NumPy. That's probably as far as we are in the scientific stack, as much we include. So we haven't put the big ones like SciPy, Pandas, and stuff like that. Is not in reduced stack. We may eventually add it in next service packs, because it is a lot of work to make it work. So it may have come eventually, but yeah, it's there is almost nothing there now. That's the first one. What was the second question?
That was not a question. I think no, Andreas was asking about SLE-BCI.
Yes.
Yeah. Oh, so let me. Yeah.
Oh, and container images and ALP not in the Python stack proposal. It was outside of the scope.
Yeah. So I can answer the SLE-BCI question. So I think you were asking how that compares. It doesn't compare. So there's a very short answer. So in SLE-BCI we offer the Python interpreter. So everything pip. So pip and the CPython interpreter in a sorry. Yeah, and I wanted to leave out setup tools because otherwise I get comments of the room.
Well, whatever you download from me, it's up to you. You can, of course. But
yeah. So these containers are intended to be used just with pip. Right? So they're not. You can install RPMs. The SLE-BCI repository inside provides some Python packages, but not a lot. Right? And you only actually get 3.6. It's actually interesting what we will do with the Python stack reduced module, whether we provide that in SLE-BCI. I think that's something that we haven't actually
decided on.
Yeah. If we provide a module, we should also have a comparable BCI based on.
Yeah, I mean, it just needs to be added to the BCI repository, or the embedded repository. But that's a discussion to be had, right? We didn't decide on that. And I think the second question you had was answered, right? I've already forgot. Alplan, yeah, the Alplan was.
Alp has two versions.
Well, yeah, so I wanted to answer that. So Alp currently, the code base has 3.10 and 3.11. So 3.10 because it's the main version or the primary version in Tumbleweed, and it just inherited Tumbleweed. And there's a written or unwritten rule in the Python team to only ever use the even versions as primary interpreter.
It's
so
very much unwritten rule. People break it, we didn't.
Yeah. So, and 3.12 will be painful. So which version, yeah, to be decided, I think still.
In other words, we didn't manage to throw it out from the host OS at this point yet, so it's still going to be part of the
So no, Python will be on the host, but it will live in its own namespace. So that decision has been made. So we will move the Python that we use for internal tools that are developed at SUSE somewhere else, so it does not interfere with what users use. So if a user wants to install their own Python on the host, they can do that. They can install whatever modules they want. They can use pip as they see fit. And none of that will interfere in Alp with what we build. So that has been separated. That decision has been made, but not implemented yet.
And if I understand correctly, and that I'm not sure whether I understand correctly, there is no guaranteed version on the host. So we will use for whatever we need, and if later we decide we want to change.
Correct. We can move our stuff as we see fit. So when 3.12 comes out or 3.14 and internally we decide we're going to switch to that interpreter, we have not made any promises to the customer that that will be supported forever until the earth turns to dust. So that goes away.
Yay!
That's the theory.
And maybe just for housekeeping, we have on Confluence this document very well, so if you have any questions, you're all internal, you can look that up. And we have on Thursday mornings PSP meetings where we still discuss this, so feel free to join. We're looking for every feedback. You might have seen Christina also announce it on all the mailing lists, so speak to us if there's any packages you'd like to have added for the future.
I don't want to be shy.
Yeah.
Good morning, everyone. I would like to talk about writing debugging modules. My name's Yuri Wiesner, and I work at SUSE Labs. So I'd like to start with a concrete example. In this case, the task at hand is tracing syscalls and determining and measuring syscall duration. Well, this result is actually from my own debugging module. We're interested in what the syscall is, in the total time, how many times it was executed, the average time, the root mean square deviation, and the maximum values of that. As you'll notice, these read calls actually take much more than the write calls, and the reason for that is that mostly the processes have to switch context, so the read call actually blocks. And the module measures the time the process spent sleeping. So I would like to demonstrate the overhead of various tracing solutions. In this case, it's a custom debugging module, and this one has only 11%, slows down your workload by 11%. This specific workload is a SCED pipe benchmark as implemented in perf. And I'm merely using the median time needed to execute the benchmark as a measure of the overhead of the solution. So if you thought you'd just record a full trace and be done with it, well, you could, but you'd be paying 59% in overhead, so your workload will be slower, much more. And if you record a trace like this, you're using the raw syscalls trace point, sysenter, sysexit. You'd actually find out page down. I'm sorry, it's not responding. Shouldn't. God. Yeah, that's a way. All right. So you'd actually find out that you had a I/O overload. That's bad because you lost much of the trace. So you fix memory, allocate some extra memory, be generous with it. And your overhead will also increase to 67% because now you're really getting every single syscall. But the workload is much slower. Plus, you've got to analyze the data after you've finished recording. So you'd think BPF would be a solution in this case, and as far as I found out, it's not really. I used a syscall tracing script that we have in the debug tools repository. And sadly, it slows down the workload much more than the debugging module. I noticed that the code uses 2 BPF hashes, so I rewrote it to use just 1. And it did not help. The overhead is still more than 20%. Now, to be fair and put this into perspective, is that the benchmark itself is a simplistic one. 4 bytes are sent back and forth through a Unix pipe, and that means there are as many syscalls as the CPU can realistically make. On the machine where I was testing, it was hundreds of thousands of syscalls per second. Real-life processes and real-life workloads do not do this. There are some examples. It's an order of magnitude less, usually iPerf3, for example. As you see, it's close to that. So it depends on the workload. And so the slowdown, how much your benchmark or workload will be slower, will depend on the number of syscalls. So I've demonstrated the low overhead of debugging modules. I should also emphasize that they provide you with unprecedented observability and control at instruction level. I'd like to emphasize the word control. You can change the behavior of the kernel. No reboot is required to load the module. You do not need to crash the kernel to actually get data. The development time is shorter. It's easier and faster to compile a module. There are fewer layers between the code you're trying to debug and the probes you're trying to execute on it. I'm looking at you, System Tap. And you can write a debugging module for pretty much everything, and that includes SLES11, where even ftrace isn't as advanced as it is now. ftrace in SLES11 is fairly basic. But there are also some disadvantages, and the main one is actually the kernel not always works in the way you expect it to work. So you may end up crashing the kernel. So you do not use this on production machines. That's basically when you're trying to make a customer run your module, you have to emphasize that this is not for production machines. There's also a caveat when it comes to K-probes and K-ret probes. They may be missed. These are instances of the handlers not executing, and there's a counter to actually indicate that a K-probe or K-ret probe has been missed. So far, I haven't figured out how to use trace points that are found in modules and instrument them from my debugging module. And the other disadvantages are not that severe. You need to be aware of how to synchronize data, because eventually you will want to keep state in your debugging module. You've got to be aware of execution of contexts. So you need to know where your probes will be executed. Will it be in process context, in interrupt context, or both? The answer may be both. In my case, it often is. You might want to know how work queues work, timers. There are many possibilities. Also, the understanding of the CPU calling conventions and the basic instruction level machine code is necessary if you want to use K-probes effectively. And the last disadvantage is that you may get unexpected crashes that take some time figuring out. So in order to write a debugging module, one needs to be able to write a module. This is a code for a very simple module that just prints 2 messages into the kernel log. And we've got a module init function and a module exit function. These are registered with these calls. And you need one include and a module license. And this is all the code you need to create a module. There's a make file that goes with that, and once you have a makefile like this, or a more complicated one, install all the necessary packages. You can use just the well-known make commands to actually compile this. There is one point you need to take care of, are dependencies. You may be loading your debugging module on a testing machine, but does this testing machine have all the symbols on which you place the probes? Because if you're debugging something in NFS code, you need to have the NFS module loaded, for example. So, and then you load the debugging module with insmod because you do not implement any dependencies. I never did. And unload it with rmmod. So I usually started the description with kprobes and kret probes, but I'd argue that trace points are more important than those. And the reason is trace points do not get missed. Trace points get executed, and also the call stack is much shorter. Well, there's no call stack because the trace point executes your handler right away without any functions in between. So trace points are debugging code that's embedded in the kernel, and probes can be attached to these trace points. A trace point can be off when it has got no probes on it, or it can be on. A trace point that is off, there is a penalty. There are 2 instructions executed, so it's almost not noticeable that the trace point's there. The API, from the API there are several functions I'd like to point out. The for each kernel trace point, this function allows you provide a callback for this function, and the callback is executed for every kernel trace point that is in the kernel image. It doesn't work for modules. There's a function to synchronize state when you're unloading your debugging module. And then there are the trace point register functions. There's a whole set of them. But for these to work, you've got to have a pointer to the trace point. And most of these pointers or these variables aren't exported, so you cannot access them directly. Hence the for each kernel trace point function. Tracing syscalls is a common task, and for that purpose there are 2 trace points. You've got the sysenter trace point and the sysexit trace point. What's important for you is the function prototype that will be inherited by your future probe. And in the case of the sysenter trace point, it's a pointer to a struct with registers and the syscall ID. For sysexit, you get a pointer to the registers again and the return value of the syscall. So if you're about to carry on with your syscall, with writing your syscall tracing module, the code I'm showing actually works, compiles, so there are no hidden parts that are omitted, except for error handling in some cases. So when you're entering the kernel, this is the probe you want to execute. The probe, as you notice, the prototype, you've got the registers and the syscall ID, and you've got a data pointer that's a void pointer that you set when you are instrumenting the trace point. I do not use this pointer. In this case, it may have some limited use. I would like to note that this has been simplified because I'm only filtering the process that has got the ID equal to my PID declared here. Otherwise, I'd have to keep state. I usually use a hash for it. So I didn't want to show you all the code with the hash. So I'm filtering just one PID so I can use global variables. I'm checking the syscall number, and if it is a known one, I save the entry time by calling local clock and the syscall ID. Otherwise, I invalidate this execution of the probe. And I'm doing something special for Futex syscalls, because I have got the ID, so I can simply say, if you're executing a Futex, please store the first argument. This is the probe for the return from kernel. As you can also see when you look at the prototype, again, I'm filtering out only my PID. I compute the duration that the process spent in the kernel. And if this diff is greater than my specified tolerance, I print a message. And this is already better than any tracings, I mean the simple tracing solutions where you capture the whole trace. You've got some filtering in place already. The resulting trace will be smaller and the entries will be more relevant. For Futexes, I'm also printing the address of the Futex word. Now, how do you hook this to the trace point? You use the for each kernel trace point function. You give it a callback, a probe, add a T probe in this case, or del probe if you're removing. These are my functions. I wrote these, and you give it the private data, which is the T probes array. And the T probes array is of a type I've declared, which is understood by these callbacks, and I'm specifying the name of the trace point and the name of the handler, and there's no data. And in these callbacks, I'm iterating over over the T probes array, and I'm checking the name of the trace point against the array elements, and if these match, I register the probe for this trace point. The same with unregistering. Non-blocking syscalls there are situations when you do not care about measuring the time of syscalls that have blocked, because you may get a lot of noise. So you solve this by instrumenting the sched switch trace point. Here's the prototype for the trace point. There's bool preempt, which tells you whether the process has been preempted or not, and the pointers to the task structs of the process being scheduled out and the process being scheduled in. What's different is that in this case is that the probe is actually much smaller. When the PID matches the PID you're trying to observe, you just invalidate the syscall. And in this way, because the NR is checked in the exit probe. So if you invalidate it, you're discounting the instances when the process actually slept during its syscall. And you've got to amend the T probes array, as expected, I hope. So now, trace points are fine, but there's a limited number of them, and when you need more flexibility, you do get that with K probes and K-ret probes. These allow you instrumenting almost any kernel routine with the exception of no trace functions, and they allow you to execute handlers or handler functions. You can collect debugging information and you can change the behavior of the kernel. K-probes are generally placed at the first instruction of a function or at any offset you choose, understanding, but provided you've read the disassembly of that function. So you know which instruction you are instrumenting. There's a pre-handler and post-handler. K-ret probes are a bit different. They focus on function return. So they are registered for a kernel function as a whole, and there's an entry handler that's placed on the first instruction, and the actual handler is executed when the function returns. I wanted also to show the PT-regs structure for x86, because this is the machine state. This is how the machine what the machine was doing when your K-probe or K-ret probe has been executed. So you may read these values, and you may even change these values, provided you know what you're doing. So K-probes in more detail, what I'd like to say, when you create a K-probe, the kernel code is modified. So there is a breakpoint instruction is inserted into the place, and when the breakpoint instruction is executed, the K-probe calls its pre-handler, then the instruction is single-stepped, and the post-handler is called. The API is simple. It's just register K-probe and register K-probes, and you can check for success, and there is a rollback for register K-probes. Removing a K-probe is similar to that. There's just UN at the beginning. The signature of the pre-handler and post-handler are, well, as I said, you get the machine state. You get the pointer to the struct with the registers, and also the pointer to the K-probe itself, so you can, for example, print the name of the K-probe. Here's the whole structure. You, of course, have the symbol name. You have an offset into the symbol, pre- and post-handler, the number of the missed counter, as I said, and some other stuff. So about this breakpoint exception is that on x86, this is usually an int3 instruction or an int instruction with its argument equal to 3. And, well, you replace just the first byte, and this breakpoint exception actually switches the stack, writes the old stack pointer, the rflags register, and the return pointer onto the new stack, and a service routine, an exception handler is executed. Typically, this exception handler stores the values of all the registers, thus creating the pointer to the PT-regs structure, as I said before. Upon returning, the IRET instruction is executed, the values are popped off the stack, and a stack switch occurs again. As for K-ret probes, they are registered for a function as a whole, and each K-ret probe has an entry handler, which, for example, ftrace does not allow you, as far as I know, currently does not allow you to, when you use the sysfs, the debugfs interface, does not allow you to do anything useful with the entry handler. But in a debugging module, you can use that. You can put your code in there. K-ret probes manipulate the code of the function so that they store the return address, use a trampoline, and execute the K-ret probe handler upon returning from the function. So the interface to register a K-ret probe is very similar to the K-probe interface. It's simple, it's nice, it works. Here's the signature of the K-ret probe handler. You may notice you don't get a pointer to the K-ret probe. You get something called K-ret probe instance. So what's that? The K-ret probe instances are pre-allocated when a K-ret probe is created. And they actually allow you to keep state for each execution of the K-probe. There is a limited number of them. The maximum is max active. And you can put whatever data you like. I usually collect this data in the entry handler and use it in the return handler. So an example for K-probes is it's actually quite easy to measure the time spent in functions using a K-ret probe, because you get the ret probe instance for free. Otherwise, you'd have to keep state for every process or every CPU or in a data structure. But this way, it's much simpler. So you use the interface register K-ret probe and pass a pointer to the ret probe itself. And I've declared it here. Here's the handler. Here's the entry handler, and the size of the extra size of the ret probe instance. And in the entry handler, I'm not doing anything special. I'm just dereferencing and getting a pointer to my data carried in the ret probe instance, and I'm storing time. Then in the ret probe handler, I compute the diff. How long did it take? If the diff's larger than the tolerance, I print a message, and I'm done with it. And the last example is changing the behavior of the kernel. We had a bug in 15SP3 and 15SP2 where systems that accumulated a large number of C groups, I mean tens of thousands of memory C groups, tended to get stuck when they were reading the NUMA stat file. The function here actually computes the counters for a single memory C group. It uses a mask in this for cycle. And then it executes the actual function that iterates over all CPUs. This is the slow part. So you've got many memory C groups, and each of them iterates over all CPUs. So if you want to get rid of as much of the cycles as you can, the simplest way, and you don't even have to read the disassembly of this function. You just set the LRU mask to 0, and this will be just iterate over all the bits, and it does not. There's not much overhead. So I defined a K-probe where I set the third argument, so that would be di, si, dx. So this is dx, this is the third argument, it's the mask. If you register a K-probe like this, well, the NUMA stat file bug is gone, it's mitigated. Well, not exactly, because another handler is needed. I need one more function to mitigate the bug, but this is the idea. As for resources, we've got documentation right in the Linux source, and also if you'd like to see some code that I use in real life, not these simplified examples, I recommend this GitLab repository. As for documentation, there are ample things you can learn about how the machine works. I heartily recommend all of these. Thank you for your attention.
Uh, Hi everyone, I'm Joey Lee from Taipei, Labs Taipei team, and my session is about the stream, succession, and something things about our stream. This talk, I prepared this talk, and Dennis Zheng cannot go here, but he also helped me, so I put his name here. He is also our stream maintainer. Okay, agenda. First, I will introduce the Shin and our association, and I will explain some process of the Shin, like review and sign and the delivery. And you saw the keyword, the name, you know who, the Microsoft requirement, and the latest is the SBAT. Okay, the first is Shin. Just in case anyone does not touch it before, so Shin is the first bootloader before the Grab 2. It only work on the UEFI firmware environment. So it's one EFI application. The pointer is a license. It's a license, the BSD2 cost pattern is more important, actually the most important, because Microsoft don't want to sign anything about the GPL3. So that's why we cannot directly send the Grab 2 to a Microsoft side. That's why the Matthew Garrett created this project and give a BSD license. After that, we put more function in the Shin, like MOK, and use a DB to verify binary, to verify the secondary bootloader, and also we support the TPM to extend some PCR like PCR 7 and PCR 14 for the SBAT and the MOK. So it's one very simple chart. UEFI firmware has the image loader, and it load the Shin, then Shin load the Grab 2 load the kernel, like this. Okay, then it can do the verify when secure boot enabled. UEFI firmware verify the Shin, and the Shin verify the Grab 2 verify kernel. Actually, this chart is simplified. Actually, Grab 2 load the kernel to the memory, and the Grab 2 request call the Shin protocol to verify the kernel. We'll have a detail later. Okay, and Shin, as we know, Shin is a project, and we use it in SLA and OpenSUSE. So we applied some SUSE downstream page, not too much, only 4, and we want to reduce that. On the other hand, a special things. I mean, I'm not sure other component, but Shin is special. All SLA and lib versions are shared one binary, only one binary. So another, like OpenSUSE Tumbleweed, use the same code, but the only difference is the built-in certificate. It's a built-in OpenSUSE CA. And SLA and the lib use the SLA CA. It's after the closing lib gap project. So lib shared the Shin with the SLA. Then another special thing is this component is Shin must be sent to the Shin review project on the upstream before signed by you know who. Yeah, we must pass the review. I'm not sure other components must do the things. Maybe Shin is the only one. So when you think maybe I have a very good idea, a very special idea to, hey, we can put many cool features to the Shin and do what's everything. Yeah, it's not what I also want to do that, but we must pass the review. It's also always a problem. Oh, sorry. The last pointer is oh yeah. It's also important. The last pointer is a version upgrade timing. It's not always upgrade. Only when the serious security issue happen in the Shin or grab 2, for example, boot hole serious. Yeah. Okay. Sorry, I did not capture that. Sorry. Oh, thank you.
So the question is, is there a strict requirement that there is only one certificate in the shim? Can't we put both the OpenSUSE and the SLE certificate in the same shim and be done?
Yes, but dangerous. Yeah, if we can put many certificate in the one shim, but after the shim be revoked, then everything revoked. So if we found maybe one big security problem in the SLE, maybe only revoke SLE shim, and the OpenSUSE tumbleweed shim maybe safe, but deep not safe. But if we put the same certificate in one shim, every certificate in one shim, then maybe if the shim be revoked, then everything have problem. Currently, yeah. Okay? Okay, thank you. Then maybe we can discuss, but yeah, it's a current problem. Current situation, not problem. One highlight, this presentation is not, I want to promote something or I like whose solution. I just want to explain the current status. Yeah, now I like it. Maybe I even hate it, but maybe, yeah, it's a recording, right? I cannot say too much. Okay, the process of shim. Maybe, yeah. Sorry, some word maybe small, but the slide will share after the talk. It's a building process for the one new shim and the shim review Docker file. We need to provide one Docker file on the upstream. Then anyone want to review our shim, they can use a Docker file to reproduce the building of our shim binary. So it's a requirement, is a request by the shim review project. And the shim, of course, we need to build out our shim. So the yellow color means is on the OBS, and the green color is in the IBS. The yellow color, we always from the factory, normally from factory and Shin project, Shin package. Then, because we all know the factory is not quite stable because the tool chain maybe change or something like object copy maybe change. So we need one stable base to build out our binary and also the Docker file. So we create one sub-project under the factory. The name is a secure dashboot, and they have one shim package. And we put a 15.4 lib base, the repo under this project. Then so our shim binary be built out for the tumbleweed is based on the 15.4. Actually, it's not based on the real factory. So then, like the yellow color shim, after build out, it has the OpenSUSE CA embedded in the shim binary, and also have the OpenSUSE sign key signature. It be generated by the SUSE sign key. Then those part is done by our security team, SUSE security team, and Johannes will create a Docker file based on the 15.4 actually the latest stable OpenSUSE release, and the Shin, of course. But before we send to the upstream, we need to strap the signature because we don't need it. Then the green color, the selection, the path is similar. Actually, for instance, just based on maybe the latest stable release, like currently is 15, 15 SP4, then generally the Shin is embedded CA and also attached the sign key signature. Of course, we need to strap the signature before send to the upstream. Okay. Then on upstream, the blue color means now we on the upstream, actually the GitHub. So our security team, Johannes, he has one fork from the Shin review and create 2 issues. Actually, we use the issues to run our workflow. And one is OpenSUSE Shin is for Tumbleweed, and the other one is for SUSE Shin, is for SUSE and lib. And it includes the Shin binary and also the Docker file for anyone want to help us to review our binary and to check, to review, to make sure it's reproducible of our building. Then it's submitted to the Shin review project. Then after some review, we need to collect maybe 2, as I remember, or 1 or 2 key man's approval. Yeah, then after that, after we pass the reviewing on the Shin review project, then the security team will send it to the Microsoft Sign by the one secret channel, yeah, quite secret. Then after the Microsoft Sign, then it send it back to the security team. So we got one Shin attached Microsoft signature and also a Shin for Slayer attached Microsoft signature. Then security team send it back to me or Dennis. So the problem is maybe not a problem. Sometimes, actually not sometimes, it's almost we were blocked. The whole process will be blocked on the Shin review project and also blocked by the Microsoft. We don't know what happened sometimes. Just like last time we sent a new Shin in last year, in the end, before the end of last year, but we got the 15.7 Shin back maybe around before last month or last month. Maybe need to wait a couple of months. Yeah. So it's the Shin review project on the GitHub. It's under the Red Hat Boot project because they host this review project. And all distros should be sent to this project for review. Not just us, not just Red Hat, not just Ubuntu, everything. Every distro, including Micro Focus or some Chrome, Google Chrome, or any distro should be reviewed here. Okay, after the Shin be signed back from the Microsoft, which means we got the signature from the Microsoft, then we will extract the signature. Then here is a bit complex because we don't want to direct use the binary with the signature in our product because we want to double check the hash of the Shin to make sure it's reproducible of the building. So we just extract some information and combine them to one file, one binary file. The name is signature-OpenSUSE and ASC. So it's a hash of a sign-based Shin and also the timestamp, link, and checksum in the PE header and the Microsoft signature. Then we update the ASC file in the OBS or IBS, then generate our real scene of the OpenSUSE tumbleweed or slave, then we deliver it. Okay, then here is a detail of the double check the hash of the shim before we deliver it. We do not really direct use the shim from the Microsoft. Yeah, so Microsoft assign back the shim, then we extract some information from the PE header because we will restore the information after we reproduce the building of the shim binary. Then we also extract the Microsoft signature and also the calculate the hash of the side batching. Then it's a one process locally, and on the OBS or IBS in the shim spec file, because we update the ASC file on the build service, then the spec file will generate shim binary again. Then we will restore the information in the PE header. Then we calculate the hash, then compare with the hash of the signed batch shim. If two hashes match, then the Microsoft signature will be auto-attached to our shim. Then we deliver the shim. It makes sure the shim can be reproducible. Yeah. So I just mentioned we only use one binary for all slave or lib versions. So here this tree is I draw this tree like this. The latest slave, the stable release. This example is not for the 15.5. 15.7 is for 15.4. At that time, I draw this diagram. So we based on the latest stable release to build out our shim binary, the package. Then some older slave version repackage. Based on we put the RPM to a lower project. Then the spec file just repackage it, open it, then take a binary repackage it because we want the serial number, the count of the package can be added for those older slave. Then some children slave version, they inherit from the loser mother. Yeah, and the lib, the yellow color box is also inherit from our shim from the 15 SP3. Now it's a 15 SP4. Yeah, like this. Okay, then Microsoft requirement. And maybe, yeah, because we need Microsoft sign. So they have one document. Actually, I cannot find all the document, but they have one document in last year to mention this. Maybe last year, I forgot. So they have many rules in the document. The first, we need to use an EV certificate, and they only sign the production quality code, which means we cannot send one development code to them for sign. And the code submit for the UEV sign must not be subject to the GPL v3. So they, for example, GRAB2, they don't want to sign GRAB2, so that's why it shouldn't be created. Yeah. It's a concern. It's a Microsoft's concern. Maybe not our company, but Microsoft say they don't want. Okay, then have one other policy. You must first submit to the Shim review project for reviewing before signing. and the call-sign key must be backed up, stored, and recovered only by the personally in charge of the rules. It's not me, it's a security team in SUSE. I'm happy. Then, okay. Okay, we need to design, the submitter must design and implement a strong revocation mechanism for everything, the SHIM load, the ready and the subsequent. The revocation mechanism actually is only one. Not only one is the DBX in the UEFI firmware. Yeah, not maybe we hope it was, yeah. And Microsoft requests more things for a new SHIM, non-SQ or no SQ flag and 4K alignment. The old SHIM do not have this. I guess maybe it's because break Lautas. Yeah, because Microsoft uploader be found a problem, so they request more policy. The effective date is 2022, yeah, the end of last year. And session alignment must align 4K page. And the session flag must not combine the write and the execute, of course, because the code and the data must be separated. And the binary must set NX combat flag. Actually, Microsoft provides one tool to verify it, so can help us to verify the EFI binary file to make sure it passes their check for their requirement, including the 4K alignment and also the NX flag. So for SHIM, Peter Jones, the maintainer of a SHIM project, now he put a patch in the end of last year to enable the NX flag, compatibility flag by default. It's out of the SHIM 15.7, but we report it. Yeah, if we want to disable it, we can use the one compiler option to disable it. Okay, then we got one SHIM. How can we know it was for the NX flag, NX memory partition? So we can modify the OVNF to check it. OVNF is the one sub-project in the EDK2. It's a firmware can be run in the QEMU KVM. So just a very simple, put the GCC option -Z command page size to the 4K. Then not just here, we need to put three sessions in the OVNF description. Is for some different stage, like SMM core is for page label partition, and runtime driver is for support the memory attribute tables, and like a DXE core or application is for NX partitions and so on. More important is this. This one is also in the OVNF description. We need to enable some, it's a bitmap. We need to enable some flag to tell the firmware we should enable the read-only and also the non-executable. And yeah, and some memory regions cannot be set to the executable. Like they have one 7FD4. We need to check the bitmap have one table say which bit is for the which memory regions. So we need to say it. And Project Mu, even that the Microsoft create one project is yes, they are developing the the firmware based on the EDK2. They claim that they used it in their machine, their Surface Zero. I'm not sure because I did not check. And they provide one QEMU firmware. The name is a Mu Tiano platform. It can be run in the QEMU to. They modify the memory partition subsystem. I did not check the code yet, but they modified it in the EDK2 to support more functions of the NX. And they provide, it's a only implementation. What I know is it provides the EFI memory attribute protocol. It's a new protocol in the spec to let the OS or bootloader to change the attribute, the memory attribute of NX flag for some reason. Kernel boot. Kernel also affect. And now, since 5.19 RC1, sorry, my English is not good. Basic sorry. This author, he added one page to the, it's just a workaround. It's the red use the DXE service. DXE service is for one stage in the UEFI for the driver execution, DXE driver execution environment. So it can use the protocol, it's not really protocol, it's one service to change the memory, the flag of the memory regions. So it direct change those regions to the writable and the executable. So it's just a workaround for the kernel can be run based on those, if we found this firmware. So, but it's not perfect. So then after that, he tried to send a one page set to the version 5 to improve the that in the compressed kernel stage. And it supports the new protocol I just mentioned in the new spec. It's safe, more safe, because the PI spec is for like a UEFI driver, but this protocol is a boot pump service, is for the like OS and bootloader is better. So, but after review, it's not finished. So the art is he sent a more patch set for these things. So now it's still under development. We are watching that and try to help to test it on the OVM and the Project Mu. Okay, so I only have 2 minutes. SBAT. So SBAT is a tag, can be used to block or revoke some untrust the binary, EFI binary. Why we need it? Because the DBS, we said the only one mechanism to revoke the EFI binary. The space in the firmware is a limit. Around, is upstream say that around the 32 KB. And until the 2021, we already used the 50%. It's almost a full, very quick. So and also, so we have we start to support the SBAT to put a tag in the EFI binary, and since 15.4 is support self-check, so the machine can self-block itself. The old machine can block itself when a new machine be installed on the machine, and old machine cannot be run. Then 15.7 fully support SBAT policy. And we can use the object dump to check the SBAT session, to check the string, and also here have 2 EFI variable, and it's save the SBAT variable, save SBAT string in the variable for checking. We will have a diagram to show up. Okay, like this. At the beginning, we do not have the SBAT string in the NVRAM, so this first version we support it is 15.4. So it's a CSV format. So we put a one string in the SBAT sessions. So when putting, the string will to check the UEV firmware. If it did not find the variable, SBAT variable, it will create one. And the user is a SBAT string. So it's the first one. Then after that, if we installed new SHIM, then the new SHIM will go to check the timestamp, day stamp of the SBAT. Not just day stamp, including the SBAT version and the day stamp. If the day stamp is later, then it will update, replace the old SBAT string in the variable. Then after that, if my machine already installed a new SHIM, but we still run the old SHIM. Why old SHIM must be blocked? Because it have a maybe security problem. So the 15.4, it can self-block itself. So the SBAT session has the version SHIM 1. The component name is SHIM and the generation is 1. But the EFI variable, it says we have installed one new SHIM on the machines before. So the component is a SHIM and the version generation is a 2. So 1 less than 2, so it be self-block. And we can also block GWAP2. GWAP2 also has support the SBAT session. So in this case, like GWAP2 is the generation number is 2, and the generation number in the variable is 3. So the GWAP be blocked. We can also block kernel, but not support yet. So the same, the kernel be loaded by the GWAP2. Then the GWAP2 call the SHIM protocol to verify the kernel. The same, we check the SBAT, but now it does not support yet because no one send a page to kernel. Maybe nobody want to touch it. So maybe bootloader first. Yeah. So but block kernel is possible. Actually we can block anything. If we support multi-second level bootloader, we can block anything behind after the SHIM. Okay, here have some case about the security violation error. I put here because I got some bug. They say, okay, I got a SHIM security violation error, but actually they are different. Have 4 cases. The first case 1 is the SHIM real have problem. The firmware cannot run the SHIM or load SHIM, so you will see this security policy validation. And the second case is a self-block. The SHIM be self-block because the SBAT does not match all to old. So it show like this. And the case 3 is normally we saw this. This blue box be actually is exposed by the SHIM because the GWAP2 did not pass the check of the SBAT or even the signature did not pass the check. So it show like if you see the one blue box, then this means the GWAP2 cannot match with the SHIM. The case 4 is a kernel. Kernel also maybe be blocked. Kernel does not support SBAT, but the kernel has a signature, and the signature maybe does not match. Maybe it's too old, or maybe should be updated, but kernel did not update, so it's also possible you see this. Okay. Maybe too much. I put too much slides as usual. So it's a SBAT policy, and at the rest, SBAT actually not just one string. Actually, back to here, like a 15.7 have 3 policies. One is a delete or original. Original policy is a first SBAT string in the string. And so if you run the MOK util to delete it, it will roll back to the original, the oldest one. And the previous is the last release SBAT. And the latest is now, or now SBAT. So you can choose which policy. It's a bit complex because I want to write one OpenSUSE wiki to play it because some guys play in it and found it's strange, the behavior is strange. So I put one table, but the more useful is this chart. I draw it. So default state is a previous. If I install one shim, it will use a previous state SBAT to override the EFI variable, SBAT variable. So we can use the MOK util to push it to the latest state. But after you go to a latest state, or you from the previous state want to delete, or we say clean to the original state, then it's impossible when the security boot be enabled. So we need disable security boot, then we can run the MOK to delete the SBAT string to set it to the originals, the oldest string. So in this case, maybe latest or previous want to go to delete or original state, we need disable security first. And after that, we can from the original state to the previous. So latest state cannot direct back to the previous. It must go to the original, then back to previous, which means the security boot must be disabled first. Okay, finally, that's a page. Next, what the next? And the point is we sometimes block by the stream review or when Microsoft sign. So the point is stream review. Now Dennis Zheng working on the upstream to try to improve our quality on the upstream to help other distros to review their stream. Then we hope other distros maintainers can also review our stream, because we cannot review our stream. Yeah, it's not make sense. So it's a closed review. So we want to build our quality. And we are try to reduce the downstream page. Yeah, because without downstream page, then our stream is totally the same with the upstream stream. Just the only difference is maybe the tool chain or some other things. So, yeah. Oh. Oh, sorry. Sorry. No,
just maybe.
No, I finish. Okay.
We move to the next speaker. What do you think?
It's up to you guys. See, then there is a lunch break after, so we can be late. It's up to you.
Exactly.
Oh.
If there is some questions.
Okay. Yeah.
If not, then we can move.
Okay. So upstream features like we are trying to support multiple second stage bootloader. Now only support Grab 2, and merge the fallback and the MOK manager EFI to the shim. EFI is for TPM measurement. Okay, is a what? Some reference document. Okay, thank you. Okay, thank you. So if you have any question, just ask me after the session. Thank you.
Thank you for... Yeah. Yeah, you see. Okay, so anyway, those that, in spite of all the odds, are waiting here, it will be very boring presentation. It will be all about hardware. So this is my Hack Week project. So, and to be fast, so I do it like this. How did it all start? My daughter came to me and say, in my brother's room, there is a radio. And I want the radio because I want to hear the hockey matches, because in Switzerland, we have this, when there is a hockey league, they have this multiplex on the radio. So I say, why should I go to the shop? I'm an engineer. So let me do it with Raspberry Pi and with spare pieces I had at home. So normally, I use the Raspberry Pi 0, this is 02, which is very wonderful because it has the same memory, but it has 4 cores, and it's faster. And that is 0W. So now, but look, when you look at this, where is the sound? Nowhere is the sound. So when you go down, you see that actually there is some possibility to get digital sound. So I say, okay, I will use the digital sound. I buy this card. It's called Hifiberry Mini Amp. It's expensive like a hell. It costs 26 Swiss francs, plus the delivery. But okay, I bought it because it's my daughter. To have a nice on-off possibility with the radio, I bought Pimoroni on-off shim, and I connected it. But I made a mistake. I turned the shim, and if you look here, I put 5 volts here. And this one was okay, because this one has just 0 between itself, but this one got -5, which basically messed up the Raspberry, because it broke the GPIO 19. Plus, it messed up, when you look at the card, it messed up also the chip, the decoder. So the problem of this is that it's frame sync, and without frame sync, I2S audio can't work because you don't know which data is which channel. So it just doesn't work. So now what to do? I looked closer and I saw that actually there is a possibility to get analogical audio from the Raspberry Pi. But what to do with the analogical radio? Audio. So I just looked, and the analogical audio, there is pulse width modulation. It means that, for example, when you have 50% UTC cycle, it is 0 during half of the time and 1 during the half of the time, and it makes you half of the voltage, so it's somewhere in the middle. If it's 75%, it's more of 1, less of 0. If it's 25%, so this is how they encode the. If you are interested, it looks like this. They are the pulses, and then according to how the sinusoid is, the zeros and the ones are a bit wider. This is a good way to encode, but it's not the best. So Raspberry Pi, they have a mode that you can switch on by audio PWM mode 2, that is so-called delta sigma modulation, that gives you almost CD-like audio, because you don't have the width of the pulse, but you have the density of the pulses, which allows you pass more data in one sample. Now, but that you have to filter it somehow. So how to filter it? So I looked through what Raspberry does. So I looked at the first version of Raspberry Pi, takes it, puts it through a low-pass filter that is about 50 kilohertz, because they are the 2 resistors that you see, they are in parallel, and the capacitor, and it's filtering out the high frequencies, but it leaves basically 50 kilohertz. It filters really the digital crap from it, and for us human, unless you put it on the ears of your dog, it will not create any problem. So I prototyped it. I know it doesn't look very nice. That was my first attempt, but it kind of worked. And I could put on the pins the audio, and I could put everything. Yeah, this is how one normally starts. It was working. But when I realized that when I put it on my ears, I was getting the audio, but when it was silent, I was hearing the old GPIO. When I started to type, I was hearing everything. When the processor started to do something, I was hearing it. It was kind of nice thing because I remember when I was still on dial-in, and we would hear everything that the dial-in was doing. So it was kind of reminding me my young years, but it was not very good for the audio. So I looked what they do in the next versions. But in the next versions, what they were doing, they actually they stabilized the voltage, and they put a gate that is basically copying signals, zeros and ones, is non-inverting, and with stabilized current. But I didn't like this because they put 2.5 volts, they had to divide it here so that they don't have big difference, too many pieces. So I looked what they do. Okay, this one I will show you how it looks on a Raspberry. On a Raspberry, it's basically this part. Here there is the two for each channel, the two resistors. The filter is here near to the buffer, the gate there. And yeah, this is how it looks on Raspberry Pi A Plus. Now, on the Raspberry Pi 3, it's much cleaner because they take 3.3 volts, a gate, a buffer, and then the filter, those capacitors so that it goes only, you get only alternative current, and a resistor so that it's biased to 0 so that you don't make pung when you put the jack in. So I decided to go with this solution. This is how it looks on the Raspberry Pi 3A Plus. Okay. So Hackwick. Now, the bad idea of Hackwick was that it was very close to the Chinese New Year. So there were no pieces that I ordered from AliExpress that were coming any near because there was like 3 weeks that nothing was shipped. So I had to work with pieces that were locally deliverable. So I had to design it. And in Hackwick, I decided I'm going to use this guy. So I took a KiCad and I designed it. But I had to design it, I didn't have a dual buffer, so I had to design it with 2 buffers. And any LDO that I found, any linear, any voltage regulator. This was my design of the filter. There is a big capacitor I put between 5 volt and 0 so that I have it nice. Then I decided, because it's a little thing and there was a lot of space on the board, so I put also an amplifier. It's an amplifier, just a normal D-class amplifier. This is very standard, very standard way of designing it. Basically, the sheet. The resistor 1 and resistor 2, they don't have the right value because that one I was experimenting with. For completion, this is how I did it. I used the jack that is switchable so that when you have the jack in, it's going to the headphones. When you have it out, it's going to the now. So the first design was this. I was really proud of myself because it took me some time. I designed it nicely, whatever. And I sent it to GLC PCB that is in China. I waited, and after 15 days of waiting, I got the board, and I soldered it. I had to, in the meantime, I had to upgrade myself because it was not possible really to do these little things with, okay, maybe Wojciech, he would be able to do it. We did, me, no. So but then was already Lunar New Year was already over, so I bought myself a T12 soldering station. I didn't tell my wife that I was buying all these kind of things, so I was intercepting the packages before she sees it. I soldered it all. I was so proud of it. It was actually working. Both channels were there. Now I listen to it, and it's nice. But then I listen more, and I still hear in it. Say where this thing is coming from. So, what did I do? I had a problem. I reacted the same way as I do when I get the L3 bug. I started to panic, and I Google. So, and I found on Google, and I found on Google that there are several things that you can do to remove the noise. One of the things is shorter tracks. Another thing, put ground on put ground around objects, around the components that are active. Okay. So then I looked at this thing and I said, maybe this 3-volt thing, it might be an antenna, because I realized that when I was going through through serial, it was not noisy. When I was doing some things over SSH, it was, I say, maybe it got, so I redesigned the thing. Oh, damn. Yeah, I redesigned it, I added something. I wanted to say, okay, by that time, things from China started to come. So I had different LDOs, and I had different buffers. So I say, okay, let me redesign it with those things that Raspberry they use. So I added that bypass condensate capacitor, because the bypass capacitor is a requirement for one of the LDOs, and it can be unconnected for the others. So I redesigned the board, and I redesigned it with the same buffer that they use. Okay. So the LDOs that I used are these 4. I say, okay, I will try which component does it, the noise. The buffers were this one. This is the single buffer, and there are 2 dual buffers. That one is from Texas Instruments, and this one is through I think OSME or something. But this one is actually wonderful, but you can't get it anymore. It's not really produced so much. You can get it from somewhere writing like 18 months of waiting, so I don't know what it means, maybe never. And for that, I had to design a special footprint, because that buffer that came from China, it was SC70, and the other was AC74, so I didn't want to have boards for everything, so I designed this footprint where you can put the smaller and the bigger together. No, not together, but alternatively. Okay. And in the design, I joined all the grounds, and I designed it the way that, and the other thing I did, I put a ferrite bit on the power line, just to, I don't know really whether it makes any difference, but as usually, I'm just trying. So these are the ground. Normally it's 5-volt plane, but these are the grounds inside it. And from the other side, I actually joined some of the 5 volts so that it doesn't go too much line, so that it has more. And then there is a ferrite bit. It's a little composite that is basically that has different resistance depending on frequency. Okay. So, and I tried to do it. So I realized that the buffers, they were not really so important. The buffers, they were all okay. The problem is LDOs. I had this one that I got from the very beginning is noisy with everything that is possible. I don't know why. It's possible that that captures the signals itself. And this one is one that should be, according to the parameters, the least noisy, but is noisy too. So then this one is that one that Raspberry Pi uses. It's okay with the bypass capacitor, but that one, it's a LDO that I looked at what HiFiBerry they use for stabilizing their voltage, and they use this one. I think they realized that it's the least noisy themselves, and that one is actually making it all noise disappear. Okay, almost. So then after that, I decided, okay, so I realized that these LDOs were what was creating a problem. Let me redo it also with the buffer, with the 2 single buffers. So I did the same thing. I designed it just that there are 2 single buffers instead of 1 dual. The 2 ferrite beads there, and everything was perfect, apart 1 or 2 boards that I don't know why, they were still having some. Now I started to be paranoid because I bought myself AKG headphones so that I hear it well, and there was still some little noise. And I tell myself, let me try something. So I put a heatsink on the Raspberry, and a silence. This is empty. I don't know really why the noise is there, but this helps. So if you have a noise, so these are the babies. These are the different babies with different versions. If you are interested to see them, I have some prototypes here. Now, as a postscriptum, with all these things, I managed to get from China also the converter that I messed up, and I managed with the new soldering iron solder it. So even the HiFiBerry card of 26 Swiss francs is now working again. So yeah, thank you. Yeah, good. Yes.
A quick question. This is great. There is no audio hat anymore in the industry because of the supply chain issues. And we were looking at the FE Pi board. It doesn't exist anymore. Some radio operators. The FE Pi board was an audio board that did a lot of what you were saying. But yeah, a lot of people went out of business with the supply chain, so this is fantastic. If you ask the Raspberry Pi Foundation how to get audio out of a Raspberry Pi Zero, for example, they'll always say, just use HDMI output. It's high-resolution audio. Did you ever find a small amplifier that would decode HDMI? Does that even exist?
No, I heard about it, that there are those ones that you can, that convert HDMI to an audio jack and some, normally there exists a HDMI things that convert it to something to VGA and audio jack, and then you can put amplifier on it. I actually have amplifier because when you saw the radio at the beginning, I had old novel swag, and there was one kind of cube that was USB 1.1 hub and 2 speakers. So I removed the speakers because they were actually 3-watt speakers. So I put it there, and with this amplifier, you have 2 times 3 watt on 4 ohm. So I used them, and there was an amplifier, so I could have used that amplifier. But then, look, if I
tiny and convenient. Right?
Yeah, but I mean, if you see, if you do just the audio from there, you have all this part. You go until here. All this part is free, and you basically can design. You can just put. The babies are here actually, so that people can see it. So there would be until the jack. You will have that part. And then you have the board that is free, and that chip, and few capacitors and few resistors, and you have 2 times 3 watt from the same thing. So it's me. I was kind of, I mean, one could do it in different way, but I'm a SUSE engineer, and I am for the hard way. So I mean, it was also kind of why I did it for Hack Week, because all the Hack Weeks I was doing, normally in upstream, I was doing a lot of reverse engineering of file formats and whatever, but at certain moment I didn't want to be staring at the screen even during the Hack Week. So I decided that I'm going to do some hardware. Okay, with KiCad I was staring at the screen the same, but it was not the same staring at the screen. So I mean, it was kind of fun. It was not really, it was not, yeah, I don't know how to say, it was not really to save some money or whatever, because by the time I was telling myself, I want to save the Raspberry Pi that I messed up. Why? Because if you go and try to buy a Raspberry Pi now, it's very hard. I needed the 02. And since I live in Geneva, that is near to French border, I found a Belgian distributor that had it, and that distributes to France. So I asked my friend who lives in France whether he can accept it, because, and this kind of way I was getting the things, because there is a supply chain problem, really. But yeah, but this, actually it's funny that all the active components are cheap. What was the most expensive of the things is the jack and the terminal. The jack was actually is almost half of the price of it, because it costed me something like 3 Swiss francs. And the terminal is like a half franc, so it's 350 that, and all the pieces, they didn't cost me that. The PCB was cheap because I made it do in China. I sent them Gerber to GLC PCB. That's the logo under, but I was covering it so that I don't have right problem, since they are not sponsors of our conference. So, so I mean, they 5 of them, it costed $2. Another 5, 4, because there were different designs, and the shipment I got it by the direct slow way that was going through some ship or whatever, and that costed me maybe all costed me I think 12 or something like this. There is another one. There is another one. There is. Yeah, I don't know how it's called. I don't remember. There is another PCB way that can do similar things. But actually, GLC PCB I like, because they kind of don't charge you extra for having it thinner, having it thicker, whatever. So if you want to see how it looks, this is how the babies, they look live. There are the different prototypes of it. Please don't steal it, because I promised it to people, especially to my manager. So they are, these ones, they are not very noisy. They are not noisy at all. I had one that was slightly noisy, but I gave it to Wojciech. So, you know, she's a teenager. They are never really happy, but she listens to the radio, and I am switching it off normally when I go to the toilet at 2 in the morning. So that's it.
Oh, it's visible. So, okay, I think we can start. This is some discussion about the build system that we use to for some tests on kernel before the contributions are merged into our product branches. This is really old. You can see that the main server of the system is called kern CVS because it predates Git. And I prepared this nice picture of the structure of the system. The Apollonius server, which most people know as most people know as kern CVS, is what users communicate with. That it hosts the main repository that people can see, and it does the mirroring, like uploading the kernels into OBS and mirroring the kernel sources to GitHub. There is a server which used to do different stuff, but now is dedicated to running the expander, which takes our quilt kernel tree and turns it into a plain kernel tree like the upstream one. And the most stuff is done by Bohosh, which is a scheduler that pushes build jobs to the builders. There is one more that didn't fit in the picture. And these builders, they try to build the user submissions for all architectures that we support. And they do some slight checks like that all modules are listed in supported conf or stuff like that. And because we have the scheduler now, we also need storage because now the builders aren't fixed to building one single architecture. They can build any architecture that is pushed to them, and then they need to get the data for some of the checks from the storage. The problem with the system is that it's continuously updated from the time since before Git, and most of it is ancient. And it sort of works, but it has a lot of limitations. Like recently, Peter, who left SUSE at the end of year, worked quite a bit on this system and implemented this scheduler so we can make better use of the builders that we have. And we aren't affected by outage of a builder because we can just configure that the builder shouldn't be used, and the jobs will be scheduled elsewhere. And this is now written in Python and has some tests. So for this part, if we do a change, we know that it works as we intended originally. For the most of the rest, like the tests, the other scripts, they are written in a mix of shell and Perl, and we don't know what they do exactly. So when any kind of change is done to these scripts, it usually fixes one bug and introduces another bug, because there is some corner case that we didn't think of, and we don't know what it does exactly. The current first limitations are that the build happens directly on the build host. There is no container, and that means that on this one host, we need to be able to build SLI 12, SLI 15, Tumbleweed 3.11, and yes, we currently have all these tools somehow installed on each of these build hosts, but it doesn't sometimes work very well. Like there is recent problem was that you couldn't build all kernels with the same dwarfs. Some version of dwarfs would work for SLI, another version for Tumbleweed. And the other problem is that for these tests, we don't have tests. So we don't know what they do exactly. And what I would like to solicit here is some input on how to move on with this system. If there are some great ideas how to improve it, how to move it into the 21st century, and so on.
I just had a question. What do you mean by non-secure storage?
Currently, the RUDA server is running NFS, and it doesn't have a dedicated VLAN, which can be changed. You can create a VLAN. You can use different way to access the storage, like it can be HTTP server or whatever, but it's what it is.
So in terms of ways that we can bring this into the future, I think the obvious one is to containerize the build environment so that it's not dependent on whatever is on the build host. But I think we can do more than that, because I look at Kbuild, I look at the build service, I look at OpenQA, I look at a bunch of other different systems, and they all have different schedulers that work slightly different ways, that are kind of containerized environments, that some do VMs, but more or less the base requirements are the same. And so what I'd like to be able to do is have a pool of hardware that can be used for all of these things. And we can dedicate chunks of them to, say, Kbuild. But otherwise, it just pulls a node out of a pool, builds the kernel. When it's done, it puts it back. When it needs it to build another one, it pulls another one. And it can do it either based on a completely separate VM, which I don't think is actually necessary for Kbuild. The boot test, yes, but the building itself, no. And I think we can use all of our hardware resources much more efficiently this way and still end up with better, more maintainable results.
And that's the problem. Currently, we don't have any isolation for the tests. They run directly on the host, and with that, there is very little that can be done for consolidation. Like, that's one of the most limiting factors right now.
So I think it'd probably work for also the tests to be containerized, right? Like, is there anything in particular in the test that needs to be, if it's running on the build host, there can't be anything in particular on the build host it needs. If it's running the same tests on every, like for every kernel build, I guess, on the same host, it should probably be pretty easy to containerize the test cases as well.
Yes, there is some data that goes in, which is mainly the specific Git tree that needs to be built. There is some data that goes out, which is mostly the KAB files, and there is intent to also store the output of the of the make, so that we can see if there are warnings, but it's currently not done. It's not like very difficult, but the structure of the script relies on the ambient authority, and yeah, we can like go here and pick this file and go with there and pick that file, and it needs to be changed quite a bit to work in a container. And there's the thing, it's a shell script which is really ugly, and every time it is touched, it breaks something. So yes, hopefully somebody will have time to work on this, but it will take a while.
Okay. I mean, this sort of work is exactly the sort of thing I think a lot of us can learn to do and should learn to do, because it's another use case for what I see as a lot of us who have been in the company for a long time, and I'm absolutely including myself in this, haven't really used any of the modern technologies that our customers are using. And it's projects like this that give us that exposure, that can see how customers are solving these problems so that we know how to solve them better ourselves. And so, like, I'd say prioritize trying to find time to do that, because it's not just about making Kbuild better, it's about growing that knowledge for our team as a whole.
Yes, we are currently using containers for tests for some of our tools which are in the kernel source repository. So yes, we aren't completely like oblivious to containers, but converting this particular thing is difficult because it's not made to run in isolation. So, and it's like it's really like problematic to touch this thing.
So that's the big hurdle then. The fragility is is the blocker, and it's, I guess the containerization would fix kind of both, as long as you can get past that, right? And then we can have versions of containers so that if something gets broken, it doesn't break the entire build system. You can just say, yeah, that didn't work, and pull it back, and just not use that version of the container.
Yes, that's the intent, like to get to something that is more manageable and more maintainable, but it's a really slow progress. And we currently don't have anyone working on this even part-time. Like Peter was working on it quite a bit, but now we have nobody again.
So we do have an open position in the file system team that's going to be contributing to this once we find the candidate for it. It's part of the kernel CI project generally, but it's going to have to build on Kbuild, and making sure the foundations are safe is the first step. So I think there's help coming anyway.
Yeah, that's great.
Yeah, I wanted to say, so we had a look into the containerization of the builders, because that's right now is a big mess, because we have to build every kernel versions. And the problem we are seeing is, of course, we need to build test like SLE 11, and there's no container, at least out of the box, that we can create with a SLS version to do that. So we will. So for now, I was only able to create a SLE 12 SP5 container using Kiwi and not the normal container build, because that's not working on OBS. And yeah, so we will need all the distributions for SLS, a container for that. That is not, I'm not quite sure how we can do that with the infrastructure we have.
But strictly speaking, we don't need like SLE 11 container, yeah? We just need a container that is able to build SLE 11 kernel. So it can be very well like SLE 15 SP4 container, just with a tool chain somehow massaged so that it can build SLE 11 kernels.
Everybody's laughing, but that's exactly what we're doing now.
Yes.
Yeah, I just want to remind the case when these build tests passed successfully, but there was a change in the tool chain that caused that the kernels built in the build service couldn't boot even. So I mean, like if we want to make this environment put into containers, something, I think it should still be the same environment that build service uses to build the production kernels, so that we actually test the same thing.
Yes, and that's one thing that the containers should help with, because currently it's really difficult to update the compilers, because you need to repackage them for this purpose, because you have 3 different versions of compilers installed on the same machine, and you have to switch between them some way, and our compiler packaging is not made for this. So it needs to be repackaged for this purpose. And with the containers that are built each for the release on which the kernel is supposed to run, they will have just one compiler that's supposed to be on that release. So that will help us to make the containers more up, like the compilers, the tools, more up to date and closer to the environment in which the product is built. But yes, we don't expect to be building 3.11 on 3.11. That like some years ago, we fixed the old 3.0 based kernels to build on 3.12 so that we could update these servers from 3.11 to 3.12. And now we don't expect to go back and start building 3.11 on 3.11 anymore. That's not realistic. Like, we don't have the base containers for building this. It just doesn't work.
Wouldn't it be possible to adjust Kiwi to cope with this? So to really create a 11.3 container? Could you repeat the question? Use the microphone, please.
The question is if we can build 3.11 container with Kiwi, and my answer is yes. If somebody is going to fix Kiwi to build 3.11 containers, fine, I will use them. But I don't think that Kbuild should include this project to like fix up Kiwi to build 3.11 containers. No, thanks.
Yeah, I would like just to add that now containers are good in general, but whether should we be taken away by this when we have the change root environment of the local OSC builds, when we don't need to install anything on the host and you can build it equally as in the build service with the local OSC builds?
The problem with building as is done in build service is that it takes a long time. Like with these builds, we are skipping the packaging part, which takes quite a while. And there were some attempts at optimizing this. And as far as I know, it went okay. If we do this and this and this, it will be 10 times faster. And somebody did a pull request, and then the maintainer said, well, we don't know if it will work for all packages or whatever, so we will not merge it, and it's still slow.
Well, you can optimize it in a way that you would edit the spec file, stop the build right after the build before the packaging side, take whatever there is in the root, OSC root, and it's quite fast.
That sounds
sort of
quite
hack,
fragile.
Oh, fragile. It's just the set line.
So I had a related problem many years ago, and the solution was basically to, well, it's a hack, but basically build the equivalent toolchain for every system. Back in the day, there were no containers in Linux. So have each toolchain separately, then it will just point to the directory where this was installed. And really the container problem is a separate issue. The problem here is the environment is fragile, but if you split the build issue on one side, then moving it into a container is trivial. And really, what the problem was trying to actually fix was related. It was basically rebuilding kernels for a lot of distributions and matching that, because the problem we had is we didn't know what we were getting was actually came from the sources. We needed to check that. So we needed one-to-one binary reproduction. And it didn't always work, and it required a lot of hacking around to make it actually match. So there was a more complicated problem, but it can be done. And in this case, it's just building the kernel. You don't really care that much about it matching one-to-one binary, but you could have the same sort of infrastructure where, and I think the script should work today, so I could share them. Maybe you can rework even, so it actually works for this environment. But it could just build the tools you need for this, and it's quite dynamic.
That's basically what we are doing, because there is OBS project that builds the development version of GCC. We pick some of the compilers that are built in a suitable version. Some we recompile because there is some missing feature in some of the compilers, so we can't use them and need to rebuild them. And the repackaging is splitting these into different directories so that you can point the build to the correct directory to use the correct compiler. And there is convoluted logic in the build test script, which examines the kernel, tries to figure out for which distribution it is built, and select the compiler. And this is one thing that is error-prone, needs to be fixed up repeatedly, and you wouldn't have if we were building in containers, because there would be just the one GCC that we need.
That provided that this container is not broken by something else, which could happen just the same as breaking your environment. But once it's stable, you should not be touching it too much. So it's really an advantage to migrate to containers in that sense, once it's working.
Yes, because it means that the containers are usable by everyone in the server.
And
sorry, to repeat, the advantage to having containers is that they're reusable and not just on the build host. It means that if we put this container for any given release in a registry, anyone can pull the container to do the builds on their local system. And rather than just having, you expand your tree, you do whatever, you can just have a quick little script that spins up the container automatically to make it super easy for anyone to use. And that means that everyone gets an identical build environment for free.
And it also means that we don't have to have our own scheduler. We can run the containers in GitLab CI or whatever else, because that's how current CI tools work. So we can plug into that if we do have containers, but we can't if we don't.
One merit that to having the same aligned toolchain, that we can get compile warnings or compile errors at the kbuild, and it can be reported to the submitter. So far the kernel warnings are ignored because it often does not match with the actual the results in the production side. But now if it's aligned, it will be useful.
Yeah, I think that this is a good point to have these toolchain identical in order to really develop in a deeper way. Check for warnings is one of these work that is currently obviously not done correctly because of the environment.
Yeah, so usually, it often that we ignore or overlook the new warnings because it's reported later once when the package gets built by IBS or OBS. And, well, very few people just watching that warnings. Yeah.
Yes, but the reason that the warnings aren't reported earlier is not necessarily because of this built environment, but it's because somebody would have to modify that awful script to also report the warnings.
So I did push a branch with this functionality just to store the warnings or the output with KDI files. And then it uses this existing warndiff Ruby script to then see what's new. But actually blocking the merge or anything like that isn't currently then done.
And I just had one other comment on what one of the advantages of containerization is so like I was talking about before, it means that everybody gets exactly the same environment, but it also means that we can have containers that say cross-compile. So you can test PowerPC changes without needing a PowerPC or PowerPC builds without needing a PowerPC machine to build it on your own host before we submit it to Kern CVS, which ultimately should build it on the real environment. But it means that all these sorts of things that we used to need to push to the server, we can put anywhere that we can run a container. And you can build S390, you can build whatever. And like I say, you get it all for free because it's a container that we all share. And somebody that is an expert on knowing how to set all that up is responsible for it for everyone, more or less, and everyone benefits. So I think I get that there's still a certain amount of bristling against containers as just being, fancy change roots, but it's everything around them that makes them so powerful. It's that to build a Docker image that can build a kernel on, say, any given release simply is 5 lines of code. It's a 5-line Docker file. It pulls the repositories automatically, and if you just specify the volumes that you're using, and you can put that whatever command line you want into the container itself, so you can still do like, Docker run make whatever. That works just fine. And you have your source coming in on one side, you have your build coming out the other side, and it just works. And so it's not that it's something that we haven't been able to do in the past, it's that it's so easy, and so everybody can share it. So that's why I'm really driving this, because it's going to be a game changer for all of us, even if we don't necessarily realize it yet, because it ends up being super easy to use.
I think that's a matter of perspective, in the sense that it is tunnel vision, because when you look it from an ISV perspective, for example, then it's not so clear, because you may want to actually switch compilers to actually check, for example, if an improvement actually breaks something on your build. You may want to use a specific version until a bug fix is available. It has happened several times in GCC that people broke things, and you actually may want to stick to the specific versions or move ahead before the distribution actually moves ahead. And this kind of flexibility will be actually more desirable. It all depends on your point of view, but it's not universally true that containers are better. Actually, what will be better will be if we could pick and choose easily, and the compilers were packaged in a way that you can install and combine all versions in one single system, if you needed to.
So containers can be versioned. So you can have,
Yeah,
if you want a new container, if a new compiler version, you get a container with a new compiler version.
But it's not trivial, in the sense that I can have a system that compiles everything in a single makefile and compare the output. I can compare several versions of the same program in the same build process.
You can't do that with kernel. It doesn't support it, because when you are cross-compiling, you add prefix, and it's not compatible with adding suffix. So yeah, you would have to package the compilers so that they are installed in different directories.
But what I meant is, so in my case, the script I used, it built the compiler, it built everything. So it had full control over that. So it will use a postfix on the, there were some fix-ups, but also it used postfix on the commands. So you had all the versions available.
It doesn't work with cross-compiling.
Why not?
Because the kernel doesn't support it.
Yeah, but that's I was talking about the general case. You're talking about the build infrastructure of the kernel specifically. But the case is, it's not universally true that containers are a solution for everything. They are nice in that they solve the issue now, but doesn't mean that our infrastructure or packaging is universally good. It's just a quick fix.
Well, the practice, if you want to do this comparison for the kernel, is that you install all the compilers, and there is some option to switch, which is the default for the cross compilers. Unfortunately, it's not so easy for the main compiler, if I recall correctly. So yes, but then the kernel build system supports switching the non-cross compiler, so it works out, and you can build all your version and compare them by hand, but it doesn't work automatically in any way. And the best automatic way is that that I can think of is that you use a container and copy out the build product out of the container so that you can compare it. And you can do it with all versions then.
And that's the thing, is that you don't actually need to copy the build product out. You just specify a volume that it uses. So there's no copying. You just use it directly. And this is why I disagree with your position, because there's functionally no difference from having every single version of a compiler installed and having a bunch of different containers available. Because you can just specify, you can do them in order if you want. You can use the same output directory if you want. You can do them serially, in parallel, if you use different directories. It's functionally no different than just having different compiler versions installed. It's just the command line you use to do it. Except that rather than just having every intricately built version of the compiler available, you have the entire build system that goes with it. And it just uses only those tools that are related to it. And you know for sure because they can't see anything else. So you can still have what you want. It just would be a little bit different than what we're talking about, but would still use containers to do the same thing.
I have a concrete question, not about talking about these theories of containers. So should we put a Docker file into the kernel source repository, and it would basically build the kernel and run the test that's currently run on the kbuild? So, and then it could be run on the kbuild servers, but also locally at each developer's computer. Like, and have it versioned with the kernel source together, not the image, but the Docker file for the image. What do you think about it? It's not.
That's an option. Like the current plan is to use the kernel tools repository to build these containers, so that if we have a need for some tool that is not available in the distribution by default, either because it's new tool that we need for building new kernel, or because there is a regression in GCC and we need to build, or binutils more likely, and we need to build older version to build the kernel correctly, then we can put it in our kernel tools repository, rebuild the container, and get the exact tool that we wanted. But most of the time it should just copy the tools that are available in the distribution for which the kernel is built.
Hi, so some comment on the stock CI solution. So I have tried using GitLab CI before, and it's pretty neat. So you could do, it works well with container, of course, but it also works with the non-containerized environment. The thing you need to do is on the worker machine, you install the GitLab worker, you configure it, and it'll pull the work when it arrives. So when someone pushes onto the GitLab repository, it can start the job, which is pretty neat, and it has something like confusion matrix, something like you can have to have 3 different versions of GCC. You don't want that, but you could. And then maybe 3 different versions of architecture and have it like 9 combination run it. And I think also schedule it, which is pretty nice. But on the other hand, I think that we generally don't want to use stock solution. And the reason is that like GitLab or anything other stock CI is generally targeted for the general developers. And kernel developers are not general developers. So we already have some stock workflow. And my gut feeling is that using K-build will actually be easier for everyone than switching to a stock solution. So just some comment.
Well, the upside of switching to a stock CI solution is that you don't have to maintain it because the upstream does it for you. But of course, the first step is to get the tests into a shape that can be used with some stock CI solution, and then we can test that GitLab works or something else works or it doesn't. But before we have the tests running in containers, we just can't.
I think the other side to that is that, at least for my last job, what we saw that upstream will maintain for you turned out to be you become one of the upstream maintainer because you have a specialized like situation that you need to use, and you start to have to argue with the upstream when you want to add this new feature just for you. Yeah, there's like a trade-off there.
So I agree with you to a certain extent about not using GitLab CI, and the reason I have for that is that part of the build process is a boot test, and we need VMs to do that. We need different architectures to do that. I don't think that fits real well into the GitLab CI model. But what I kind of had in mind for this, and why I was talking about having multiple schedulers across different clusters of different services, is that if we had, say, like a Kubernetes cluster that we were running, and we could have, just spin up a pod on one system to build a test kernel, and then you can spin up a harvester instance on another, or even on the same node. It doesn't matter. That's the whole point, right? Where part of the output of the build test, or maybe an intermediate step, is to build a quick small VM that just does a boot test, dumps all the results to the serial console. If there's, if it crashes, then maybe we save the crash dump information, and then it can report back from there. So rather than have it be, this one-stop shop now where it's kind of all does it together, you'd end up with this multi-stage environment. But ultimately, for the end user, as long as you get the report back in the end, there's nothing really functionally different for you, other than you could probably inject jobs yourself, which you can't now. I mean, you can by git push, but it wouldn't be more general. The idea is that it could be more generally available, and also have dynamic scalability based on what was happening in the LSG in general build environment.
Yeah, and eventually it has to be extensible as well, in the sense you can. Eventually it has to be extensible as well. Like, we will not just do a boot test, but once the VM is up, we would probably run XFS tests and MM tests on it and get all the results, and wherever it fails, you kind of compile it with whatever the previous version is and give it back to the person who's committed. But of course, it takes computing resources, but then eventually we would want to be more and more confident about what changes we put in.
Yeah, and this is the long-term goal, being able to do more automated testing than just the build tests. So one of the projects that I started up, I guess 5 years ago, more than that now, when I was still team lead of the file system team, was to try to start up a project to do kernel CI automatically. And it made sense in the file system team because it's the workload that's most easily virtualizable. And the dream is to be able to boot some of these systems and run a series of tests based on what has changed since the last test. And so this would be like, this makes more sense when we're talking about commits going into the production branch, where you can say, well, this change only modified XFS. Do I really need to test the entire MM system or the scheduler as a result, or can we target the testing just on XFS? But if there is something that changed the MM system, then maybe we need to do broader testing, and that might be more involved. And we can key that off of based on what files were changed during the commit. And right now, this is entirely out of reach for what we can do. But if we start putting together this pipeline of build jobs leading to test jobs, then I think we can end up having a lot more automated testing than we're doing now. And it means that this is testing that you don't need to do necessarily yourself on your own systems, especially given how many of us work from home now. That means less noisy machines at home maybe. And in the long term, it could even mean that we could push systems into the cloud if we needed to, or push tests into the cloud, because then that means we don't need the actual physical hardware to do it, and it doesn't make any difference to anybody because you're not touching it yourself. So it's all of this ends up being a multiplier at every stage to end up making things a lot easier.
Yes, and this conditional testing is already implemented in many stock CI systems, but we don't have it, and we are miles away from it.
Well, sorry, maybe it's a stupid question, I might be out, but isn't there already a lot of testing done in the, there is a lot of testing already done in the OpenQA, so maybe it's just different phase, right? One phase is building, but the other is testing, and yeah, there is OpenQA, but yeah.
Well, there is the kernel is specific in that if you can't put the OpenQA test, it doesn't help you that much. You need to get these critical errors as soon as possible.
Hang around for a minute. Sorry, he was starting to walk away, and I want to hear more from what QA's perspective is on this. Sorry. So, Pavel, I think that OpenQA is actually used a fair amount for kernel testing, isn't it? I mean, I know there's a few kernel testing teams that do it, and I've seen the result of kernel testing jobs.
Well, yeah, it is used. We are also testing in the clouds. There are nightly builds tested. There is LDP. So yeah, it is used.
And if you've ever had to work with QA on an issue that's been particularly hard to debug, it's actually pretty powerful, because you occasionally will get just the report from OpenQA, but it actually has the capability of generating a crash dump and saving it, or letting you step into a live system, and all of these things that we're not really doing right now. And yeah. So I agree with you that if we can have this be end-to-end, and trust me, I'm not trying to put you out of a job here, that we can all take advantage of it, because I think QA does a fantastic job in doing the assurance for what we're going to release, but being able to have those targeted tests while we're developing means less test case failures later, and I think that makes everybody happy.
Yeah, well, and there is also a lot of APIs around it, so you can schedule the tests, of course, via API, and you can also gather the results via API, so yeah.
Yeah, it's also a matter of having smaller regression window and making it easier to find the problem. Like if you test very early, even before you merge the change, then you have chance to catch some classes of critical errors before they are merged into the branch.
Yeah, if I remember correctly, that QA team does perform tests for the kernel of the day, so for some branches, but not every branch. And if we can test, so to say, every submission, then it really narrows down the regression. But I wonder that if we do more tests, and it has to be performed also for every architecture, right? So, for example, PPC on S390, and we also, at the same time, we talk about cross-compiling. How does it work both?
So I'll admit most of my focus has been on x86, because that's what we have the most hardware resources to support.
Yeah.
And there will there will be problems that crop up, even on, say, file systems that only affect one architecture over the others. I think of S390 and page dirtying, for example. Yeah, sure. And so that's something that we'll need to figure out. But I don't necessarily think it's a problem that we need to have as like the immediate goal, right?
I just wanted to say, if anybody is interested in helping on working on K-Build, we have a weekly call on Mondays. Just contact Michael or me, and we can invite you, and we can discuss further there.
Do you want to test?
Hello? Test, test. Check. Hello, I'm Jim. This is Dario. Today we're going to talk about some experiences we've had with Git-based packaging workflows. We've been playing with this stuff, or at least I have, on and off for, better part of a year. I'd go down some path, hit some dead end, back up, and so yeah, we just wanted to talk about the experiences and maybe pass some of that experience along. And there's certainly people in here that are probably a lot more knowledgeable on this stuff than Dario and I, and so if you have some suggestions or feedback, we're welcome to hear that. So the goals when we started on this were to perform package maintenance in Git right alongside all the upstream development we do. And at the same time, leverage the build service to do building I mean, it's what it's made for, right? It builds for many repositories, many architectures, so we want to take advantage of that for doing package builds. We've quickly found that we needed to use gitlab.suse.de as kind of the canonical source for everything, primarily because the open or the public Git foundries don't have access to stuff like IBS and our internal labs where we like to use runners to deploy and test packages. So along with that, we wanted to, whenever we make some changes to Git, have those automatically pulled into the build service, built and published. And ideally then get some notification from the build service that that's complete so that we could continue on with some CI pipelines back in GitLab or GitHub. And deploy those built packages to some test machines in our lab and run tests on there. With the idea of, any time that we want to do package submission, we could just go to some nice dashboard, see that all the testing is passed, and, confidently submit this stuff without worrying about problems. Something like this. A stretch goal we have is, which we don't have work, at least I don't yet, is the ability to do local OSC builds in this environment, which is now Git. The workflow makes it really easy to do upstream builds, of course, and any make check style things in the upstream project. But since, in my case anyway, I don't have the source services file or which can generate a tarball to build packages, I can't do OSC local builds at the moment. But definitely want to be able to do that. It's a nice option. If you're working offline, you want to do an OSC build minus no init, you have a build environment already there. You can actually build a package, maybe test when you're offline. So we encountered lots of problems along this endeavor. The first was no mirroring functionality in the community edition of gitlab.suse.de. That may have changed, I don't know. I thought there were some talks of that. And to work around that, we actually have a virtual machine running in our lab infrastructure called CodeMirror, which runs a set of systemd timers to mirror code from upstream repos to gitlab.suse.de. Another problem I already mentioned is some of the public gitlab.com, github.com, public Git foundries not being able to reach our internal resources. An interesting problem that I encountered when I went to submit a package based off of this workflow was that there's restrictions on source service modes. You can't have a source service mode that enables server-side runs when you submit to something like factory, with the idea being that that source service could run while the submit request was under review. To me, I think this is something that we could easily work around. I mean, when you do a checkout of a package that's under factory review, you already get a notification about that. So why isn't it possible that when we submit a package to factory that has a server-side mode enabled, that we couldn't just inhibit runs of the service while the package is under review? Another big problem is, go ahead, Dirk. Pardon?
He said he can answer that if we want.
Oh, yeah, let's hear it.
It's not a problem when you are under review of a submit request. It's when the review is being accepted and it's in the distribution. Then the distribution maintainers do not want the sources to change, right? So you want to have a change process for every source change, because in the SLE world or in the Common Cartier certified world, every source change needs to be peer reviewed with at least four or two people. So you can't have server-side runs because that would be source changes that are not reviewed. That's the reason.
So we worked around this problem, at any rate, by... I'm not going to pick anything up and throw it. You're safe. We worked around this problem by some level of indirection. So, for example, we have a develop project, virtualization project, in our case in OBS, where we submit to factory. So now we have a virtualization staging project where we allow source server-side runs. When everything's fine there, we can just go to the develop project, do a manual run, which should give us the same thing as in the staging, and then submit that stuff and not have to worry about infringing on this restriction. So another problem we encountered, or I have as well, Dario has this as well, is how we handle the factory branch. I like the name factory for this branch, and all's fine. I have the branch. It's based on some upstream release tag, and I have a bunch of commits on top of that. When a new upstream release happens and I want to rebase that branch off of that release tag, that works fine as well. If I have any upstream patches in the meantime cherry-picked in, they're pulled off on the rebase. But then when I want to go push this to Git, I have to force push it, right? And I don't know, I haven't investigated a workaround for this yet, but maybe there's some merge strategy that I can use or something like this that allow us to work around this problem. At any rate, it's one that I haven't worked around yet. And an obvious workaround is, to tag, put some prepend or the version number on there. So v9.3.0-factory. But the downside of that is, in the service files and workflow files, you already have a branch name in there, and we would have to go and change those things, which kind of defeats the purpose of automation. Another problem is the package change log. So currently, source services have a changes generate option, and you can enable that. And what that'll do is, from some previous commit when this service has run, it'll look at all the commits since then and take the Git summary and add them to the change log, which is fine for factory, but for SLE, where we need things like JIRA references or bug references, this doesn't work so well. So we were thinking that we could investigate ways maybe to enhance that changes generate code to maybe add another parameter or something to say, hey, go get this other thing out of the commit message that we can put into the change log that satisfies those requirements on the SLE side. So, something we can explore with build service folks maybe to provide such an enhancement. The other problem is one that,
In regard to that, we for OpenSUSE Salt and the version that SUSE Manager ships, we do that essentially that we store the change log, and town crier is used to essentially render and manage the change log. So what you do then is in the source service, you just extract the change log from Git and just overwrite the change log file. And then because you have the pieces of the town crier snippets, you build the change log before you force push your branch. Meaning you can, even if you cherry pick different commits to different branches, for example, from factory to SLE, you can just then mush the bits into the change log you want to have, and then just let OBS pull that file from your Git. It's not ideal, but it's the best you can do at the moment.
Yep, thanks. The last problem here is one that Dario's hit more than me. I don't know if you want to say something.
Does it work? Yeah, it's just a minor thing because it can be easily handled, or I don't know if I should say handled or worked around. It was just funny to discover it and not so funny to debug, which is that if I have, of course, the service file needs to be there in the in OBS, in the OBS package. Instead, I tried, and it seemed to work, to have, for example, the underscore multi-build file part of the Git repository and put in the root directory of the package with a extract file, I think it's named service. And so I did that. And when I did the same for the constraints file, it seemed like it worked, but it didn't. It doesn't actually. And so I figured it out, at least in that way, that you can do that for multi-build, but not for constraints. And so now they are both there, but it was something that took some time to understand. Just that.
So anyway, how do we get there with these goals that we talked about? Today, we have source services plus some SCM/build service integration. And the source service, I'm sure many people in here are familiar with this, TAR SCM, OBS SCM, SCM Bridge, and there's others. Anyway, the link here has a chapter in the docs about the integration, actually. So source services are also documented, but this link is for the integration between OBS and the Git factories. And in the future, there's this thing called Git native packaging that, you know, the folks who do this stuff for a living are working on, and Ludwig actually has a talk at 1600 on that, so plug that a little bit for him. So just quickly, source services from the docs, it's a collection of tools used to manage packages in a trustable way. And all the commonly used source services are recommended by the OSC package. So if you have that installed, you have most of these already installed. At the package level, you define what services you want to run in a file called _service, which lives right along with the package sources. And this thing can be run locally or within the build service, as I said, which is controlled by this mode attribute. And here's actually a link to all the info on source services. This example is from the libvirt package, at least how I'm working on it at the moment. And it uses tar SCM. I have the spec file and a few other things in with the sources and extract those out. So nothing really special here. Mentioned that the services can be, there's various ways to trigger these services. One is manually. You just run the thing manually on your workstation, commit the results. And the others are via webhook mechanisms. So the first is what's termed run service. And what this does is the webhook fires when there's some commit or pull request to Git repo. And it just runs the source service specified in the link that you provide in the webhook. So you specify a project and a package, and it'll run the service file in that package when, you know, on some Git event. The other is a workflow based, and it's similar, except there's an associated workflow file which is associated with the user's a token ID belonging to your user. And that file contains some instructions on what to do when on a Git event, like a push or a pull request. Pretty simple little box here showing the manual services. I mean, nothing special. Run the service manually and commit the results. And then push to, you know, send a submit request to factory or wherever you're needing to go. And there's many, many packages using this, right? This is kind of the setup I was using before trying to move to a more automated flow. Wrong way. So run service, not a whole lot different. An event occurs in Git. The webhook fires. Source service runs, fetches the code, pulls it down to the build service, builds it. There's no notification on run service that I've seen that anything's happened other than, okay, I'm running the service, immediately returns. If you want to know when this stuff actually built and published, you're going to have to go and poll for that, which is what I'm doing. Derek says here he'd be freaking out probably. So apparently there's a RabbitMQ bus that you can listen to such events on, but I don't know much about that. We need some examples or whatever to go that route. And then the workflow, similar to the other, except you have a step where the workflow description is fetched first from the build service, and then it executes the, whatever you have in there, which is generally go run source services, fetch the code from the Git, build it. And the workflow for pull requests, at least Dario has had some success in receiving events from the build service that things have built and so on. Since I'm not supporting pull requests at the moment, just push events, I'm not seeing this type of notification. So yeah, I go and wait for the builds. This is an example of one of those workflow files. This is the libvirt one. So the first snippet here is a factory rebuild. So a trigger happens, a push event to the Git happens, and I say just trigger the services of this package and this package which lives in this project, but only on a push event and only for a factory branch. And the little snippet below is the same for my SLE branch. And this is kind of how in a diagram, how I have the thing set up right now. And what I did was decide to have 2 repos in Git for libvirt. One which is the code, just mirrored upstream, and another which contains all of my CI-related stuff. So this workflows.yaml, GitLab CI.yaml, any scripts that I need for polling and deploying and testing and so on. With the idea being that a push to either one of these will start the whole process and build, deploy, test. Because if I change anything in the CI stuff, I want the same done as I change in the code. And another interesting thing, I decided to put the spec file in with the code because it has bugs. It needs fixed just like code, and it also needs associated change log entry when you make some changes to the spec file. And so some push event happens to either one of those. Webhook fires into the build service. That token associated with my user points back to this workflows.yaml living in the libvirt CI project. Build service pulls that down. Some magic happens. It reads that file, says, oh, I need to fetch code from these repos, fetches the code, builds it. I then wait for the build. I do that by using a runner in our lab that polls IBS and said, hey, is this stuff available yet? And once it's there, then I deploy and test it on runner in our Utah lab. That's it for me. I've wasted enough time, so.
No, it's fine.
On you.
Look, 18 minutes. Right, thank you, Jim. Let's jump to QEMU and say, or try to avoid saying a lot of the same things, because most of the motivations, for example, are the same. So basically, one difference is that if you now want to interact with our QEMU source code in general, so either you want to build not necessarily with OSC build, or maybe yes, but even if you want to build the code that we ship in QEMU, still working, okay, yeah, fine. If you want to build the code that we ship, the QEMU code that we ship in factory or in a SLE version, whatever, which means a certain upstream release of QEMU plus all the downstream patches and backports and whatever, it's fairly complicated. It's fairly complicated. You have to do partly, you have to do that partly through OBS. You have to start with doing some checking out the OBS, the packages from OBS. Then there is some environment. You have to set the environment in a certain way and prepare some Git repositories. Then you have to run some obscure scripts that are, although it's documented, but they are inside the package itself. Then everything has to go well, and then you can start, checking out the sources or trying to build them, which works, but is not ideal, especially for, let's say, casual contributions, or not even contributions. Maybe if someone which is not deal with the package all the time and every day wants to help with with a bug or with whatever activity. So we wanted to make this a little bit easier. Especially because one of these people that wants to fiddle with the package without learning OBS is my boss, and you want to make your boss happy. The same also for contribution to the package. Why not? Because QEMU, and we're happy about that, is used, and we get contributions used, for example, in the build service, and we get contribution from Dirk, from other people, internal contribution from the rest of the company from time to time. And we really want to, and oftentimes they are not following the workflow, but I really, and believe me, I don't blame anyone for that, because it's really unusual and different from any other packaging workflow that we have. So it would actually be a surprise if they would. And so yeah, this is another motivation, which is kind of shared with what Jim said, but even more pressing for us. And yeah, of course, as Jim said already, if the sources were just stored in some Git branches, then you could just, provided you know the name of the branch, which could be factory or SLE15 SP5 or V800 factory, depending on what you choose, because the branch naming problem is the same for QEMU as well. And then you can check it out and look at the code, the final result after all the downstream patches are applied. You can look at the CMOD commits, which would then represent the various downstream patches. You can build it either, also locally, but with the same caveat that you cannot do it from the checkout of the Git branch. You can do local builds with OSC build, OSC build, but in a slightly different way. But for sure, you can build it with the upstream build methodology, let's say. So for QEMU, it's just configure and make. And for contributing and proposing modifications, since what Jim said is true, and we decided that we would use GitLab, because from GitLab we can reach the test machine that we have in the Provo lab, and vice versa. But then what I just said, that I get a few contributions to the QEMU package from inside the company. It's also true that I get very few, but not zero, contributions to the QEMU package from the factory branch, of course, from outside of the company, so from the OpenSUSE community. So I really didn't feel comfortable to move everything to GitLab, at least the factory side. So I am for factory, which is the part of this thing that I have already there and already mostly working right now. I'm doing it on GitHub and with a pull request model. And it's already effective. I already accepted the first pull request from Andreas. So yeah, this is same as Jim's diagram, but more complicated, because why not?
Looks cooler.
No, because the arrows are all tilted. But yeah, I mean, it's the same. So as I said, I let's put the accent in these things that I just said about pull requests. So the thing that I wanted to try to stress, although yeah, it's ugly enough that it's hard to say what I wanted to make, if I wanted to make anything clear, is that from a contributor point of view, it's possible to ignore about anything about this side and live all the time in the GitLab or GitHub, and let's say GitHub because it is like that for QEMU right now. Yeah, all the time. So a contributor would open a pull request and against the github.com OpenSUSE QEMU repository. And then a bunch of stuff that Jim already described happened. So I don't have an example. I don't have the YAML file here or the service file. They are similar to Jim's one, slightly different. I can fish them from OBS later if there is time and interest and show them. But the difference maybe is that I don't have for now 2 repositories. My workflow is workflow YAML file is in the same repository. But yeah, then yeah, the same communication and magic through token and webhooks and whatever happen between GitHub and OBS, and the pull request is created, and then it starts to wait for the package to be built in OBS and for the results of the build to be reported to it. At the same time here, what happens is that a branch is created, a new package is created, which the code that is used for this package that is branched is the code of the pull request, which is very nice. So we are actually building whatever it was in the pull request from the contributor. And yeah, fetches the code, blah, 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 it's built. And when it's built, the notification is sent back to GitHub. And yeah, and I have screenshots for that, just to make things a little bit prettier than these ugly boxes with arrows. And yeah, and then this is the ideal workflow, right? It's not too different from the actual, but a little bit. And then, yes, as Jim said, there is this thing that, and this is the part that I am still working on and that I don't have in place yet. We, besides build checks, let's say, so besides building the package in OBS because it builds for all architectures and distributions and stuff, we also want to do some runtime tests in the Utah lab through GitLab runners. So somehow there will be this notification that packages are ready in OBS because we are still talking factory. Of course, as soon as we start talking SLE, that will be in GitLab, and it's all easy. Here, you probably can tell already that it's a little bit more complicated, but ideally, GitLab runner in the Utah lab would be able to fetch these packages that have been built in OBS and do the runtime test and also report back the results of that phase to the pull request, at which point, when everything is green here, the maintainer, which poor guy, but I mean, it's me, so who cares? And cannot really live only on the Git side. It have to have I mean, one party to be partly here, but also still a little bit on this other part. Can basically merge, accept the pull request, which will trigger automatically the again, the interaction between GitLab and OBS and the devel project for the package will be updated with the code of the pull request, which is no longer the code of the pull request, it's now the code of the main branch because the pull request have been accepted and merged. And then yes, and this is fine actually, I was joking before, it's not a problem interacting with OSC, of course. The maintainer can submit to factory this the result. So yeah, I told before that I would have screenshots. So yeah, this is proof that it's working. Basically, the pull request, the checks that started, and yeah, this is I'm still, but it's fine. It just says that there is need for a review before accepting the pull request. The checks are ongoing. Then here you see that the branch, the package has been branched to a special one related to the pull request. And here you see that the checks are starting to become green because they have App and OBS has built some of the package and is still building some other variants. And yeah, and when it's all green, we can go on, or if it's red, we can just reject it. So the first problem, let's say, or the first thing that we cannot really that you have to consider, which wasn't the ideal workflow, but it has to be handled a little bit different, is the one thing that Jim already said, but we also have heard the answer already from Dirk. So yeah, it's basically that this step here assumes that I could submit, as a maintainer, I could submit whatever I have here directly to factory, but whatever I have here is basically a service file, and everything is and the content is automatically generated when the service file run. But we heard that we can't, so yeah, basically that would be what I have there. So yeah, service multi-build and constraints, because as I said before, they better be here, or at least these better be here instead of generated. At which point I can put them there both, and the rest, yeah, it comes from the service run and the server side service run, and I cannot submit this to factory. So as Jim said, I tried to put it in pictures, but yeah, the result is again not very clear. But what we have, what we did is to have a staging the project, and all that I described before happens between GitHub and the staging project. Then the submission after the pull request have been accepted part happens still done by the maintainer after he has done a local checkout of it and a manual run on the local copy and then a commit. The trick is that basically the service file in the staging project, and in the real develop project from which we submit to factory is basically the same, identical 100%, except the mode of the service or services themselves, because of course in this in the real develop project it's manual and it's triggered like this, at which point oh, sorry, yes, just at which point I don't have any longer the server-side generated stuff, but I have the real file. Please.
I had the same problem and I solved it, although it's very stupid how I solved it. You need to locally anyway do an OSC command. So what you can do is you can just, if you run OSC service run all, you get, without the service prefixes, locally all these files. So what you can do is, and what beautifully works, is you literally just do a CP from your then locally generated files to the target, which is then in your eyes, in your case, the QEMU level project.
So you still have two projects or two packages.
Yes, but
instead of triggering the service, you copy the files.
Exactly.
Okay,
because you anyway need to go to the command line to do the actual submit request.
Yeah, whatever. The goal is to get from here to here with everything being the same. With the only exception of the prefix that come from the server-side run, which we don't want. So yeah, sure, we can do that instead of manually running the service, but we still need two packages basically, which, I mean, it's not the end of the world. So that's what I was saying about GitHub and GitLab, and about OBS and stuff that are inside our network, because in the slide of which is basically the same as this one of the ideal workload, I said that I want when I know that the build finished, I want to run runtime tests in machines that are in our lab. I used to say Provo, but it's not in Provo any longer. Close enough, maybe. and yeah, but of course, either GitHub pull requests. So while I am on the GitHub.com side, or even OBS webhooks or whatever, how do they? It's not like they can reach our test machine in the Utah lab. So this is, as I was saying, being worked on. I don't have it working yet. This is where I am a little bit behind Jim. Is that I want to do basically something similar to what he said he is doing. So I need something that on the right side of the firewall, which in this case is inside our network, so in the lab, find a way to monitor either the PRs, PRs on GitHub, or the builds, the OBS builds of the special packages that are branched and created when there is a pull request. And yeah, there are multiple ways of doing that. I have to do some experiments and see what works best. So there is a GitHub API for checking whether there are new pull requests, their status and stuff like that, even for making comments.
Sure. I was there as well. There is this rapid notification thingy, and I built a tiny package around that. Maybe I can show you to this. Unfortunately, nobody jumped on this train yet, but maybe it helps you.
Yeah, that's also what Jim was saying. So these are just examples. If there are good ways of doing that, yes, these RabbitMQ services, we are happy to try and use them. We would need some examples or guidance or whatever to understand how that works, because I've never done anything with RabbitMQ in general, not even with this service in particular. But but the concept is that as soon as I know from something, a VM, I mean, a service file, whatever, in the lab, that I need to do something because a build has completed, then I can do exactly what Jim is doing. So I can trigger a GitLab runner in any of the test machine. It can do all the runtime tests that I wanted to do. And then, since I am, I've been building this PR-centric workload on GitHub.com, I need a way for this thing in the GitLab runner to contact GitHub and interact with the pull request and signal it somewhere that the runtime tests have been done and are either green or red. But that's easier because, as I said, there are these GitHub API for example, making comments to pull requests, and hopefully it's not possible from GitHub to reach the machines in Provo, and luckily this is the situation. But the other way around should be possible because it's just the internet, and I hope we are able to reach the internet from inside the lab. So yeah, and yeah.
Yeah, but I just wanted to say, from my point of view, I just played a bit with this, but from my point of view, all the interaction between either OBS or IBS and either GitHub or GitLab should be or could be done using the webhooks, because I think that the OBS/IBS is can call a webhook when a build is either succeeded or failed, and the same works the other way. So GitHub or GitLab, they can call a webhook when there is a new pull request or a new tag or even new comment in the pull request. Well, whatever. So yeah.
Yeah, and I don't know if I understood correctly your point. For what I've understood it, I would say that I agree, but the problem is that how do I set up a webhook on github.com in such a way that it does something in a machine which is behind our VPN. Sorry? But how do I mirror pull requests? No, sorry? Yeah, but, and also it's not. I don't only need mirrors. I need to interact with a github.com pull request. Why? It's a, well.
Yes, I think this is possible to configure.
Yeah, of course.
Yeah.
At least on GitHub. GitLab progress.
Yeah, I don't know. I can do some gating before starting the runtime tests. Like start them manually after having reviewed the pull request. But yeah, or just I skip this this runtime aspect for the contributions from outside. Yeah. Well, let's see. It's interesting, and don't have to solve it now. And this was exactly the purpose of the talk. So, sure, and thank you. And yeah, other things are the one that really Jim already mentioned. So, no, the first one he didn't, because it's again something that QEMU, a feature. I was about to say an issue, but it's a feature that QEMU has, or the QEMU package has, and not many others, as far as I know, or at least not libvirt as themselves, which is that we apply a decent number of patches to submodules as well. QEMU upstream as submodules, and we patch with downstream patches or backport these submodules. So yeah, this is something I found a way to deal with it. It would lead to diagrams even more complicated and ugly than the one before, so I didn't have time and didn't want to draw them, but I'm happy to talk about how I, let's say, solved this problem for now. Yeah, either if there's time or offline, it works. And then there is this Git naming, Git branch naming thing for the factory branch, which, yeah, basically I am going on to one and then back to the other and then to one again. So I started with these, using V711, where this is the base version of QEMU that we have in factory at that point, and then factory, and then create a new one when we advance, when we move to a new upstream release of QEMU. Then I went back to factory, but with the problem of force pushing. Then I really don't like force pushing, so maybe I will go back to this one, unless, as Jim was saying, we find a better way of handling this situation. I really don't dislike this too much. There will be a lot of this branch in the repository, which is a bit ugly. Knowing which one is the current one, it's probably easy, because it will reasonably be the highest version and then factory. So The bad part is that we have to then change things in the service file and the workflow. This is a bit inconvenient. And that's it. You want to go get the floor back for the reference, but I don't think there is much to say, right? Except for
really.
questions, which there were already some, but please go on. So. Yeah, sorry.
Okay. Yes, but this is a general problem. Probably quite some people face. And if it's a security issue, maybe someone from security should have a look at it and advise how we should do this. No, it's okay. It's the thing about GitHub, security, whatever. So, for example, we have an OpenSUSE account there. Or SUSE account, we pay some money. I could imagine it's about this security certifications that our code must not be on a foreign company's. Yeah, yeah. Yes, but if the whole CI is triggered from GitHub, even it's GitHub, but it's the made sure that a SUSE employee with the OpenSUSE account only has whatever authorities to manage and trigger this, then it should be safe and should somehow be triggering something internal. And if it's an issue, someone from security should review this or should advise how we should do this.
How are you giving your own credentials to a GitHub product while keeping them safe? If GitHub is doing the pushing with your credentials, you have to give your credentials to GitHub.
No, I have the credentials internally. I have a token here, and if I get a notification, I do my tests.
You're doing the pushing, not GitHub.
Now, for example, I have this web token thingy with CI, where an automatic build is triggered. The build is finished. In fact, I did this. The build is finished. I monitor whether the build is finished. Get the sources from OBS. And build this. There you don't have. Anyway, you could make a token for your GitHub account. Make sure that only an OpenSUSE account is it. Put it into the internal repository into the testing system, and on notification get some GitHub stuff, and you can be made sure that only a SUSE employee had.
What I'm hearing is it's a simple matter of code.
Yeah, but that's my fact. I mean, it's probably possible, or somehow someone from security should advise how we shall do that. Yeah, anyway, someone should review this, whether it's safe or how this should be done. Otherwise, we cannot use GitHub. We have to use GitLab.
No.
Then we are close. Then we are close source company.
No, because I mean, so there is for. Yeah, well, I'm not sure we are still. During which the IBS QEMU package is a link to the OBS factory one. And if I accept an OBS, a contribution from a random user which has an account on OBS, and then it's mirrored because it's a link during the web, because I yet don't know which QEMU version. Yes, it's a link in developer visualizations too. In devel virt sli 15.6 whatever, 5 whatever.
You can do there whatever, right? It's outside of the business.
So I will
and then I have the test running on the inside the network in the machine developer lab which is running on this code, which is basically coming from OBS. It's not GitHub, it's OBS, but it's still someone in the world which managed to create an account on OBS. It's the same. Yeah. It's not a matter of tokens. It's a matter of someone sending a pull request to the QEMU, sending some change to the QEMU package and me wanting to test on a machine where I can test it. Because I can buy a runner in.
Depends on how the worker is configured. So my assumption was that the worker is configured as internet network access. That's a problem. If the worker is in an isolated public network that is not trusted, and after this CI job is done, you throw away the hardware, you never use it again, then there's also no problem. But as long as the worker is configured in a way that it has access to the internal machine or through the internal network, then you have to try anti-block by running external code that does not review. I don't know how your worker is configured. I was just assuming, right? So feel free to tell me that I don't know how it's configured.
No. It's not actually, it's not running for now, so we still have to configure it as we want.
Yeah, also, if you accept the request from somebody, I'm not sure that I understand, but if you accept the request on OBS, then I suppose you review it.
Yeah, of course, it's not automatic. So there is something public, but you review it and then you pull it inside. But there is the review.
Yes,
if
that's
it's automated, then everyone can do something at 3 a.m. and
that's what I said. Yeah, that's what I said before. That I mean, there is nothing already implemented right now, so we can probably maybe made it look something like that. Ideally it wouldn't, because so I would have the test run even without having to do the review, and so I know that if the test fails, maybe I don't even care about reviewing. But
that's enough to this.
Okay, so hello. Today we'll talk about KOP Build, a tool that we created at the kernel live patch team to make the creation of live patches easier, right? So who am I? My name is Marcos. Working for SUSE for almost 5 years. For these 5 years, I spent 3 years in the L3 team working with BTRFS, Ceph, and other storage and other issues and other projects. And for one year and a half, I'm in the Labs Core architecture team, working, creating kernel live patches. So that's the agenda for today. I will give you a quick recap about kernel live patching subsystem and how this works. About the tooling before KOP Build, what we use it to use. Problems that happen when we create live patches and things that we need to take care of. Support for live patching on SLE. KOP Build, and the future, which I will talk about KOP Convert and how this impacts our live patch creation, right? So first about kernel live patch subsystem. First of all, a live patch is just a kernel module, like a driver, like a .ko file that has special structs to set up the live patching. So the module loader, it keeps some ELF information about symbols. So the live patch subsystem, it can look for some symbols that are not exported. I will talk more about it later. We use ftrace. Ftrace is what we use to set up the live patching. And so we transition every task, which is not calling a function that will be live patched, to transition to a patched state. And if that task is using the function to be live patched, it will be retried again. And the transition is finished when all tasks are in the live patched state. So this is the sample live patch that we have in the kernel source. It's the most simple one that we just replaced the command line in the proc command line output with that this has been live patched instead of the entire kernel command line. And here it shows basically the structs that we set up to create the live patch. So this is the entire module. So we have the KOP funcs where we show the name of the function that will be live patched and the new function that should be called instead. And then we have the KOP patch on the other side where we show where we link the objects that will be live patched. In this case, is the VM Linux itself. If it's other driver, we should name the driver on the KOP func struct. And on module init, we just enable the live patch. So this makes the live patch subsystem to call ftrace and to start the entire process. So live patch prerequisites and tooling, right? So we have some prerequisites about it. And the first is that live patch shouldn't depend on other modules. So we shouldn't request for the customer to load additional modules when we are creating a live patch. Live patch is a standalone module, as I said before. It's just a normal KO file. We should create a live patch for all supported code streams. Currently, we support 69. I checked that yesterday, 69 different code streams. But that changes for day to day because they get out of support. Live patch check if the symbols used or live patch are available on all supported architectures. And we currently support x86, the default and RT, the S390 and PPC64. So first of all, I would like to talk about KOP CCP. KOP CCP is basically the heart of the live patch creating process, about how we do it. What it does, all scripts and tools that we have do the setup or process the output of the KOP CCP.
And what it does, it processes kernel code and creates a closure of code to be live patched. So as I said, live patch is a standalone module, so every definition, every function, every reference needs to be standalone. So what we set up on KOP CCP, we set up the object directory, the source directory, the live patch object, if it's a specific module or VM Linux, the IPA clones, because some functions, they are inlined, and so we need to live patch the colors. All colors of that function should be live patched then. Work directory and a lot of other information. As I said, tooling is pretty important in this case because we have a lot of things to feed into KOP CCP. We have CCP policy scripts, which check for which symbols that will be live patched or used, if they are exported or not, and other checking about which includes to use or which definitions to copy and paste in the final live patch. And also KOP CCP needs the entire command of the original source code, how it was compiled or generated the object code. So that huge command line that the kernel creates for that file, so it needs to be fed into KOP CCP. And what's the output of it? So it generates a file containing all the functions that will be live patched per source file. So if we have, like in that case that I showed before, then later I will just show that we have this command line proc show here. This exists in one file, right? So we need to pass that file and that symbol, and then KOP CCP and works around everything. And it generates the code. So, and it generates a list of symbols that are exported and not exported, so we can handle that later. And for not exported symbols, KOP CCP generates a list of externalized symbols, which are pointers to symbols that will be populated at module init phase using KOSIMS lookup. Because as they are not exported, we need to use them either way, so we ask the kernel to provide their addresses so we can call them to make the code to behave like before, and we just include the fix for that specific problem. So we have the kgraph patches, which is a repository that we use to process the KOP CCP output, which is a spec file. This is responsible to set up the basic projects to create the live patch. And we have different branches for different kernel families because they have different module init, or because we need to lock modules lock on the most recent ones, the 5.14 kernels. So we ended up having different branches for different kernel families because of some differences they have. Someday they should be merged, I hope, because it makes things easier and we don't need to think about which one to pick, or yeah. We have the kjar tests, which is Python scripts that use QEMU that install the live patch RPM generated and call a reproducer of the bug, which is usually a bash script or a C file calling some syscalls, or yeah, just setting up something to test the exactly function that are being live patched. It runs VMs in parallel, so sometimes it's very quick to test if the fix was applied correctly. Stores the output and stuff, and expects a well-defined structure of directories for the live patch to be tested. And so that are all the tools that we currently use. Now I will show some problems while creating these live patches. So code streams have different configs enabled or not. So we need to check which of them are affected and how they are affected sometimes, because sometimes modules are built in, sometimes they are external modules, and so this needs to be adjusted case by case. Files got renamed between code streams, so this is also needs to be adjusted. Different object files that are parts of a module. Very recently I was checking one of the live patches that I needed to create, and on upstream, that object file was part of one module, but in the older code streams, that were two different modules that was using that same object file. So as I said, it can change drastically between code streams. That doesn't happen a lot, but when happen, we need to check case by case too. So we can have code inline in different architectures, because different architectures use different strategies to compile code and to optimize. So when the code is inline, we should patch all colors of that code, because it's inline, it's copied. So we need to make sure that all colors of that function are also live patched. And we have the IPA clones, which is installed by installing the kernel default live patch devel. And we use then the kgraph IPA analysis, which is a project that get these IPA clones that is generated by GCC when compile the kernel, and finds all functions that inline another function. Yeah, so it mounts a tree structure where we can check all functions that are affected by that inlined one that we like to live patch. And so, as I said, the code can also be optimized, not inline, but optimized in a way that we need to inform KOP CCP to not rely on externalized symbols, because they are optimized. So, and then it asks the KOP CCP to just copy the code instead of referencing it. And also we can have the problem of duplicate symbols. So sometimes you are just referencing an externalized symbol, and there are two symbols with the same name, and you can end up calling the wrong one, which can cause problems on runtime, or as a friend of mine said, on the client side, so on the customer side. So yeah, so we should take a look in those cases where we are using an externalized symbol with where the symbol is duplicate on a module. The support for live patch on SLE. Each released SLE kernel update has 1 year of support. So if a new update is released today, we will create live patches until next year in the same day. So currently, I checked that yesterday we have 69 code streams being supported, being from SLE 12 SP4, SP5, 15 SP1, SP2, 3, 4, and SLE 15 SP4 RT. That's the first code stream that we have RT support. And we have the current list of all supported kernels in that page from SUSE. It's updated each time a new code stream enters support, or it ends the support. So there is a list there with specifics, kernel version, start of support, end of support, code stream, and yeah, all information that's basically presented here. So KOP build. So the project was born thinking about how it could be easier for the live patch author to create a live patch. Yeah, it does a lot of stuff. The first one is create a default message, including the necessary information for the end live patch. It does a good amount of checking about duplicate symbols, symbol availabilities, if the file is there, which configs are there, if which code streams are affected for a specific CVE. Checks for the kernel source for all patches that are backported or not, or if they are missing. Sometimes we get issues while you create a live patch that some patches were backported, missing some stuff between the code streams. And so we then talk to the to the developer that backported the fix. That also happens. So we need to take a look in the backported solution. It checks for the final built live patch and checks because we run KOP CCP in our machines, which is x86. But some symbols that KOP CCP thinks they are available here, they are not available in the other architectures. So KOP build downloads the modules and kernels for PPC64 and S390 and checks if the symbols are there. If not, so the live patch author needs also to include them or to ask KOP CCP to avoid using externalized symbols or dead specific symbols. And it already creates the structure that KGR test we will use later to make the testing. So yeah, it's an entire suite for live patch authors to use, making it easier. Before this solution, we have scripts. So from time to time, okay, now I need to check if I have the updated sources. Okay, now I need to check if the symbol is available. And I need to check. And yeah, from time to time, it's easy to just forget one of these steps. And some of these mistakes take a huge amount of time to just redo everything again. So that's why KO build was created. Here are the basic steps to create a live patch. So the first ones are environment and variables that I use to set some default directories because it's easier to set that by default because that doesn't change. Otherwise, if I change the KOP data dir, we'll need to re-download a couple of RPMs all over again because it checks if the code streams have the data already downloaded. So that's just an example of how this is used. So the first step is to call setup, and then we pass the CVE number, the BSC, the Bugzilla entry for the live patch request. And this is used to create a directory inside the inside the work dir directory, what I call it a project directory. So that's all contained there. And the CV number is used by the KOP build to search on kernel source for all backported fixes related to the same CV. So we can just grab those fixes and apply later. So here I will just use the same example that I showed in the beginning to change the command line proc show. So this file funcs expects one file and functions there. And then we need to inform the affected architectures. So here we support only 3 and we can pass any of them or all of them. So after the setup finishes, we call run CCP, which calls KOP CCP, passing a lot of information. I think that I have this here. Yeah. And so it generates the output LP file that we will use in the next part. Push, where we push the finalized source code to IBS and then wait for it to finish. Yeah, it's just an easy way just it's like OSC status when we push something to IBS using OSC, so it has a similar behavior. Prepare test, which creates the directory that is needed by KGR test to test the live patching. Currently, we upload the results to 3 different servers, one x86, one PPC, one S390, and we run the tests there for these 3 different servers. And then I created these KOP format patches, which basically call git format patch, but including all code streams that are affected by that specific live patch. So this is the same file than before, but now generated with KOP CCP. That's the exactly same file. So in the beginning of the KOP P command line proc show, I just added a new PR info, my fix here. So let's say that this code needed a fix, like to check a pointer or something like that. We would include here at this point, and the rest of the file, yeah, not the rest, but that's the only function that we live patched. And so we can see here that we have the KOPE saved command line. So that happens to be a yeah, I forgot to include the symbol. Okay, but then just to show you that that's basically a sharp pointer, and this is a private symbol. This is not exported one, and so we don't have any way to reach that symbol. So we have that structure there called KLP, KLSIMS relock, which then is used on module init just to make sure, just to call KLSIMS lookup to find the address of that symbol and to assign that to that pointer. So we can just the reference on the live patched function. So that's what KLP CCP does for us. It detects the symbols that are not exported, creates these externalized variables, symbols, and creates a basic structure for us to search for that symbol on runtime. So as I said before, KLP build does a lot of checking, verifies if the files exist in different code streams, if the object exists, symbols, duplicate symbols, and it creates a JSON file to include every necessary information for the next step, which is the run CCP1. Just showing here that we download RPMs for all affected code streams. That's a couple of them. I believe it's eight RPMs that are downloaded per different code stream, and we have the PPC 64 and S390 here just to check for symbols, for the externalized symbols after the CCP ends its processing, just to make sure that the symbols are available and not crash on the testing phase. And it looks in the kernel source for the patches and yeah, things that I told you before. They run CCP2. It grabs a lot of information just to be able to find all affected code around the function that we like to live patch. And currently, we can parallelize the KLP CCP, so we are processing 4 files at a time. It consumes kind of a bunch of memory, so I fixed it to 4 until now. It grabs 2 or 3 gigs, using only for instances, in my experience at least. And yeah, and for the cases where some code is optimized, we can rerun CCP again using the -- avoid ext and passing the symbol name. So KLP CCP is instructed to not use an externalized variable and to copy the code, and yeah, so it works on all architectures the same way, right? And at the end of the run CCP, it grabs, it checks for all generated code and groups it, so we can minimize the effort of creating different versions for the different code streams, because at the worst case, we would need to create 69 versions of the same code, but never happened. But I had to create about 10 or 12 recently. Because of minor changes between the code streams. But there are some codes where we just need to create 1 live patch or 2 because the code doesn't change much. For example, some more obscure drivers, that's the case. But for networking and stuff, it tends to change quite a bit between the code streams. KGR tests and kgraph patches and KLP build push. Yeah, just apply the fix. We copy the generated output for KLP CCP, apply the fix, push to IBS, check the status if the build is okay. The live patch author needs to create a script that will test and try to reproduce the original CV, or at least hit the same code that is live patched, just to ensure that we didn't make any mistake, just to ensure that it won't crash or anything like that. And this script will be used by the prepare tests, which will create a basic structure for the KGR test to be run. Currently, it downloads all generated RPMs from the IBS, copy the test case, copy the JSON code streams, and creates a tarball, and then I transfer to the 3 different servers that we use to test. Uses Cumulum currently and 2 other VMs for PPC and for X390. And then KJAR tests, which is the last step of the live patch preparation, which starts VMs that installs the RPMs with the live patches, runs the script and expects it to fail or not. And yeah, and stores logs and stuff, so we can check what went wrong. Currently, we have some macros to make sure that the live patch function was actually called, because it's easy just to get excited and create the test and the live patch function isn't called. So now we make sure that the function that we just live patched is called by the test. So yeah, so I try to cover all aspects of applying the live patch and ensuring that the code is called and it works. At least it returns the expected output. And the last one, just create the format patch that creates the format patch cover letters and with all necessary information for the live patch reviewer, including all code streams that are affected by that specific live patch. And yeah, it's basically a format patch with other stuff. It copies the commit for the test case too, which is stored in a different repository. But yeah, that's basically it. And some considerations about it. So as I said, we still need to think a lot when creating a live patch. We have a lot of differences between the code streams, tools, and things that can go wrong or can be different. We have some tools like the kgraph IPA analysis that could maybe be integrated into the KOP build, or when we pass a function that is in line, KOP build can, okay, this function is in line to this, and in 5 different functions, it could, yeah, automatically just warn the live patch author and say, okay, I'm doing this because this function is in line, so I'm using the colors instead. Yeah, as the result of this tool, I've learned a lot of stuff about live patch creations, about the details, and about everything about KOP, CCP, and kernels and differences and stuff. And we have a plan, maybe to one day open source the KOP build to enable OpenSUSE and maybe other users to other distributions to create live patches for their own machines. It wouldn't be difficult, but it would require to rework some code to avoid relying on SLI binaries and on IBS. But yeah, that's not a priority right now. KOP build is still under heavy development. But once things calm down, there's a plan for open sourcing it. So the last topic that I would like to talk about is that about the future of live patching. So Chaos Sims was removed from upstream to be used for out of tree modules. So our current approach wouldn't work in the future, because how would we use symbols that are not exported otherwise? So there is the KOP convert or something like it, because there are discussions about the naming and how it's being used until this point. So what it does, it post-processes the final KO file, the final module. It creates relocation entries for all undefined symbols, and then the kernel module, the kernel loader, once this loads this live patch, the kernel itself would call KLSims because it's inside the kernel, so it is allowed to do that, to locate the symbols, and so everything works out of the box. Yeah, I did some tests for the KOP convert for our released live patches, and it worked flawlessly, yeah, as we expected. And so once this got merged in the kernel, maybe you can start using it, and so we wouldn't need to rely on this resolving here. These steps here could be removed, the relocation stuff, and yeah, because the KOP convert would just create relocation entries for that. KOP CCP and KOP build would need some small changes for the result code. It will be a couple less code because we wouldn't need the externalized handling. And KOP build is currently being discussed on the mailing list. Since 2014, it's been there. Recently there's been some effort about upstream it again, and so new discussions came into the light again about its currently usage and how we could rely on the output of KOP CCP and other users of KOP Convert could also update how they use the tool. But maybe it's time for us to make an extra effort for it to be merged recently, make our life easier, and yeah. Okay, so do you have any question?
Hi.
Hello.
Great talk, Marcos. I was talking to Nikolai earlier today, and I had some ideas.
Okay.
I have 3 questions, 2 of them that lead to the third one. So the first one is, how long until you get a patch, a raw patch from an upstream mailing list and end up with a patched machine, for example?
Okay.
How many hours do you take to do that?
That depends. We usually wait for someone to backport into the kernel source. That can be quick or not. That depends on the
yeah, I mean,
okay, once
if everything
that's
is ready, you have no obstacle, nothing.
Yeah, it's a couple hours. If the patch is straightforward and we don't have to create a bunch of different versions, it's a couple hours.
Okay.
Yeah.
And the second question is, you can't build it locally? You have to use IBS?
Yeah, that's a good question. Yeah, maybe we can build that locally too. But oh, yeah. But then on IBS it builds for all supported architectures too.
Okay. Well, yeah.
So
because my third question is not related to releasing to customers or anything. This idea I had while talking to Nikolai is, as a kernel developer myself, I build stuff and then I build the module and then I need to SCP the module to the VM and then reload everything.
Okay.
So how difficult and, if possible, how practical you think it would be to have a mechanism to develop on the host and then create a live patch that applies on my VM, and instantly I have the modification there?
How difficult, you say?
Yeah, how difficult it would be to implement this workflow.
Okay.
That's why I was wondering about how long it takes, and you can build locally.
Yeah, just to return to your first question. So sometimes the live patch creation step is very quick because the fix is sometimes minimal. But the process of creating a reproducer for the problem takes a lot of time, sometimes. So, and sometimes we try to reproduce a CVE, double free, and yeah, sometimes the creation of live patches is 1 hour. The reproducer takes 3 days, let's say. But for you, yeah, it's the same stuff once.
Yeah, I would like to repurpose live patching to adapt to my development workflow.
Yeah, that will be much quicker because maybe you just have one code stream, right? That's that specific machine that you want to create. But yeah, maybe we can talk that later about how that would be possible. Yeah, maybe we can improve also KOP build just to make this easily to create for one specific case.
Okay, thank you.
Any other questions? Okay, so thank you.